Good afternoon, everyone, to the second session of Lonza's Operators Seminar. We're glad you could join us today. We're going to get started right away. First speaker is Ryan Pessa from Western Wood Preservers Association, where he is Director of Government Relations. Ryan is responsible for monitoring and responding to regulatory and legislative initiatives affecting the preserved wood industry in 17 Western states. Ryan has extensive background in legislative policy and communications. He has a Bachelor of Arts in Political Science from California State University, Long Beach, and a Master's of Arts in Political Management from George Washington University. Ryan will be giving us an update on state and regional regulatory issues. Thank you, Ryan, for joining us.
Thank you, Grady. Just two corrections. Western Wood Preservers Institute, and I think the most notable thing about my biography is now that I'm a father of one. Just had my wife gave birth to our first son in December. But jumping right on into things, going to be given the update on what's been happening here on the West Coast. And I've broken it up into two different objectives. The first objective is going to be talking about regulatory stuff. We're going to be talking about the Washington Human Health Water Quality Standards. We're going to be talking about drip pad regulations in Washington and everybody's favorite California Prop 65. The next objective is going to be a legislative objective. We're going to be talking about treated wood waste disposal and the aftermath of SB 68 veto, which took place in September of last year. What's been going on with pesticide fees in California, Washington's environmental product declaration. There's a bill moving through that could potentially impact us or in the future. And then the infamous Neo-Niconatoid bills that are popping up everywhere. So let's just jump on into the regulatory stuff. We've got, when Obama was president, we had the EPA under his administration promulgated some unattainable human health water quality standards. These standards were petitioned by industry, including Western Wood Preservers Institute. When Trump took office, his administration started to unravel what the Obama administration put together, and we were moving favorably in a good direction. It kind of came to a screeching halt when two industries or two entities from the environmental justice community came through and filed a lawsuit. We were a party to one of the lawsuits. It was discussed that both the lawsuits would combine into one. That never happened. And the judge has just been sitting on the case, probably waiting till the election came. And before the election took place, another party filed another suit. So there's three suits against the EPA in regards to the human health water quality standards. WWPI did not pay into the third suit, and a part of me is a little bit glad we didn't, because it would have been a little bit of a waste of money, given that the new administration's a Democratic administration. He's going to undo what President Trump did. So I think all the lawsuits may just kind of dissolve or evaporate, and Biden's going to undo what Trump tried to undo, what Obama tried to do. So the pendulum swings the other direction. We'll see how that comes about. I think Biden might be a little bit more sensitive to the regulated community more than Obama, but we'll see. Only time will tell. So hang on to your hats for that, and I'll keep you all posted on what comes of the human health water quality standards in Washington. Next up, we've got the Washington drip pad regulations. If you're operating your plant in Washington, this is a reminder that you accumulate your waste from the drip pad on a central accumulation area, not a satellite accumulation area, and you need to label your drum as such, central accumulation area with the date and such. A few of our members have been noted that a satellite accumulation area was in violation, and the biggest difference between a satellite accumulation area and a central accumulation area is the fact that one has to be gone every 90 days, regardless if the drum is full or not. And the other is it has to be gone once the drum is full. And the state of Washington is enforcing the more stringent policies. So if you start filling up your drum on your drip pad on January 1st, that drum, whether it's full or not, needs to be off-site by March 21st. And if you start filling up a new drum on March 1st, that new drum needs to be off-site by June 19th. That's pretty much every 90 days. What I just gave you an example. We've been working or trying to have a conversation with the department to educate them on what EPA has done in regards to this. The EPA has written up some extensive guidelines on allowing drip pads to use a satellite accumulation area instead of a central accumulation area, specifically because how unique a drip pad is. There aren't any other waste streams in the regulated community where they sweep or clean up their waste streams weekly or daily like a drip pad. So these are the conversations we're going to be having with the department and explaining to them the need for more relaxed regulation for our drip pads just because they're very unique. Are there any questions in regards to what's been going on with the drip pads? And if there are, you can just raise your hand, or if any of you have been visited and been affected by any of this, if you could just raise your hand or let me know, I'd greatly appreciate it, because we're just still trying to figure out the actual impact of all of this. Now, everybody's favorite, Prop 65. The good news is the new regulations that they're trying to push through do not affect us. They are looking to amend and change the short form safe harbor warnings, which really are applicable to small items that are smaller than 5 inches. They're looking to enforce that by putting a requirement that the short form warning can only be on products that are small. They're including food products and the like. So this technically doesn't impact us, but I do have a question as well. As note, please raise your hand so I can see you're in the chat if you or your plant uses a short form warning like posted. And this isn't just applicable to entities working in California. If you sell product that goes into California, whether it's a pesticide, a treated article, or anything else that has preservatives in it, you need to be complying with a short form. Even raw wood material needs to, or not a short form, excuse me, needs to have a Prop 65 warning. And so if anybody is selling product and using the short form, doesn't look like anybody has their hands up, which is a good thing. We don't need to use the short form. All wood products fall under what's called a wood dust. Why isn't it going forward? Can you please advance the next slide? I thought I was doing it well. Perfect. All wooden products need to have a wood dust exposure warning, like I have shown on the screen. And the requirements for wood products is that you provide an annual notification to all downstream customers. And the newest criteria for this is notifying an authorized agent. This new authorized agent requirement took place last year, where there's a designated agent where your notification gets sent to. And you only need to do it yearly. You do need to provide it to every downstream customer. So if your product goes and touches 7 different entities before it gets to a retail location, you need to have 8 warnings, which includes the retail location. If these notifications are too much for you, we also know of a organization called Western Wood Product Association that has a service for Prop 65 warning. If you're interested in utilizing it, I'd encourage you to contact Diane or Kevin. Their email addresses are listed in the slides. If you can't write it down soon enough, feel free to email me or reach out to Lonza, and they'll help get you their email contact information. My email will be at the end of the slide. So moving on to the next objective, we've got this mess in California that deals with treated wood waste disposal. I've been expending most of my time, I should say all of my time, on dealing with this issue. So in September, Governor Gavin Newsom vetoed SB 68, which was supposed to continue the treated wood waste program as we know it, allowing treated wood waste to go to composite-lined landfills. Come January 1st, the sunset that was in the statute to allow treated wood to go to a composite-lined landfill sunsetted and expired. And January 1st, landfills started rejecting treated wood waste and said you have to go to a hazardous waste landfill. Caused a lot of issues for industry, whether you're a retail wholesaler of treated wood or you're a plant operator that has scraps that are just broken wood that you can't sell or ship, you're going to get impacted because you have to take that treated wood waste to a hazardous waste landfill. Starting January 1st, you need to label all your treated wood waste with a sign that says hazardous waste. You need to have a date for the accumulation. You also need to have on the same sign, whether it's a solid, a liquid, or gas. Obviously, treated wood is a solid, and you have to check off that it's toxic. And this little sign that you need to have is on every waste stream for treated wood as it gets to the landfill. And what we're working on to remedy this issue is this process of variances. We've been working with the Department of Toxic Substance Control to start implementing variances. The department is in the process of putting out 6 different variances. On the slides only have 5 listed. The 6th one is for an emergency disasters, which don't really pertain to us. The first 2 variance types is a small quantity generator and a large quantity generator. The threshold being of the 2 is at 10,000 pounds. If you're below 10,000 pounds, you'd fall under a small quantity. If you're 10,000 pounds and above, you'd fall under a large quantity. These types of variances are primarily geared for a physical brick and mortar entity and not really utilized for somebody who's moving from location to location like a contractor. So if you're a small business or if you are a plant operating in the Sacramento area or anywhere in California and are under 10,000 pounds, we would encourage you to get a small quantity generator variance. The cost for the small quantity generator variance for one location is right around $1,000. And for every location after that, it's going to go up around $700. It is a pretty pricey variance fee. So think critically whether it's important for you to get this and allow the disposal of treated wood waste or go to a hazardous waste landfill. The third variance type is a transporter variance, and we're hoping that this variance will help revive our businesses here in California utilizing treated wood. This will allow a contractor to not have a physical location, but take wood from whichever house they're working at and go straight to a landfill with their treated wood waste and not needing to go to a hazardous waste landfill. The questions for all 3 of these vary. The application for a small quantity and a large quantity are right around 70 questions, but for a transporter, it's right around 26 questions. So it's an easier variance type to apply for. We don't know how much it costs. That's supposed to be rolling out soon, and we're supposed to be finding out that information more. The next 2 types of variances that I have listed, handler and transporter, and then disposal facility, really relate to landfills. The handler transporter one are the transfer stations that are littered throughout California, and then the disposal facilities are the specific landfills. The department has said that today's the day that they're going to be accepting applications for variances, and they're only going to be accepting landfill variances to open up the ability for disposal. We support that disposal idea. I think the more entities accepting treated wood waste, the better it is for our industry and the more wood we're going to be selling, which is a good thing, given that a lot of contractors have been really hit hard not being able to dispose of treated wood waste, and the fact that they're just going to be sitting on their hands accumulating this treated wood waste. So those are the different variance types. There is a workshop that's going to be taking place Friday the 19th at 1 o'clock Pacific Standard Time. This workshop is going to be put on by the Department of Toxic Substance Control. They had one just last Thursday with 550 participants. So I would encourage you to join, ask whatever questions you need. There's still a few clarifying questions that we have as an industry that need some clarification. So I'd be happy to share that link with you. Feel free to email me at the end so you can sign up for this webinar presentation on treated wood waste disposal in California. So while this variance system process has been moving forward and we've been working collaboratively with the department, WWPI has been working creatively to help remedy this in other ways. And one way we've thought to do that was through the request to repeal the alternative management standards of treated wood waste. In early January, the Department of Toxic Substance Control requested to the Office of Administrative Law a repeal of the standards that allow treated wood waste to go to a composite lined landfill. We thought differently that this repeal of this code section is not applicable and it should not move forward. So we hired a law firm to draft up a memo and submitted that to the Office of Administrative Law. And they came back with us and saying, we're not accepting any public comment. So we've decided to stop at this juncture with this avenue and find other avenues we can to help remedy the issue. But at this point in time, the repeal of the alternative management standards is kind of a moot point. If anything does arise on this issue, we will bring you up to date. Other things we've been working on in conjunction with the Treated Wood Council is the assessment of a few reports. The first report, which is on the screen, was published in 2008, and it really was the genesis of classifying treated wood waste as hazardous. The department analyzed a few preservative types or treated articles with preservative types, copper azole, ACQ, and creosote, and determined that they were hazardous. They had hazardous characteristics, except for creosote treated Douglas fir. Through that, they were able to require treated wood waste to go to hazardous waste landfills, and from there was the alternative management standards that opened it up to go to all landfills. But we've hired Integral Consulting to really evaluate their research methods and the way they conducted this report to see if it all is sound and done reasonably well. The other report we're evaluating is the implementation of Senate Bill 162. This report has been a little bit of the bane of our existence because the legislature with SB 68 has noted that there's a lot of high rates of non-compliance with the treated wood waste program in California. So we've hired Mal Foster and Longi to research and review the report and identify that the violations that they're citing in the report have no environmental impact. And that's really important because we're going to be using that justification for the lack of environmental impact to show what changes we need to be made to the AMS so that we can move forward and have a better program that's better for industry and better for our generators and our users. The last thing that's going on is the legislative front on this addressing disposal. This year, AB 332 was introduced. WWPI and TWC, Treated Wood Council, are the sponsors of this bill. This is a committee bill, which is very different from last year's SB 68, which was a member's bill, like one single member legislator. A committee bill means it's all the members on the committee are authors of the bill, and it gives the bill a little bit more visibility and credibility as the bill moves forward. The only issue is we have a little less autonomy to advocate because we have 7 different people we have to educate. The other important things about this bill is it has an urgency clause so that when it is signed by the governor this year, it'll take effect immediately, and it won't be till January 1st to come into effect. And our goal is to amend AB 332 to incorporate a lot of the AMS standards in there so that we don't have to wait for the Department of Toxic Substance Control to draft new regulations. It'll already be in statute and it'll have taken effect immediately. It is a difficult year for the California legislature as well as other legislatures given the COVID precautions and limitations. Each committee is only having 2 hearings as opposed to having 3 or 4 committee hearings per month in other years. So we will see how the cookie crumbles in this regard, but given that it is a committee bill and has an urgency clause, a lot of the deadlines don't apply because it's an urgency matter. So we will keep you apprised as this bill moves forward, and hope we're not going to have any unexpected setbacks. Also in California is a proposal by Governor Gavin Newsom to increase the fees on pesticides, pesticide sales specifically. Currently, there's a 21 mil assessment on the first sale of pesticides. And a mil is equivalent to 2.1 cents per every dollar. So it's about 1/10 of a cent. And the proposal from the governor is to increase it to a tiered system. And that tiered system is going to be linked to the signal words on the pesticide label. As you'll see at the bottom, there's a chart. You'll see that most of our pesticides really fall under the tier 3. So by 2024, 2025, this 21 mil is going to pretty much double to 45 mil if your pesticide is in tier 3. The goal for this increase in fees is to deter or transition away from harmful pesticides, as well as pay for increased enforcements. WWPI has been working with a coalition in the ag community and a lot of home care products like Lysol and the like to really advocate that this is the wrong time to increase the fees on pesticides. The coalition we've been working with has been calling this the COVID tax, and it's really vibing well with the legislators to think that when they buy the next bottle of hand sanitizer, it's going to be taxed more than in previous years. And this tax doesn't apply to the consumer, it does apply to the manufacturer. But just to think that we're going to be taxing the thing that's supposed to be killing this virus is the wrong time. We've been making the argument that California is really gung-ho about building affordable housing, and increasing the fees on pesticides is going to increase the cost of building materials. Building codes require treated wood, and if you're going to increase the cost of treated wood, your affordable housing is going to increase. Our arguments have been taken really well. We've got more meetings with legislators to convince them that this is not the right approach to be taking. I haven't taken a break to ask if there's any questions, but if anybody has any questions, feel free to raise your hand in the little chat bar thing. Next item we've got is Washington HB 1103. This environmental product declaration doesn't directly impact us. In the law, it does say composite lumber, which I had to realize that's plastic lumber, and mass timber. The bill is affecting public works project, and they're trying to understand the impact, the environmental impacts of products. I know our industry has looked into these EPDs, environmental product declarations, and we haven't really moved too far into that. But the reason why I'm bringing this bill to your attention is that it is trending in Washington to have these EPDs for a lot of products. And the lobbyist we hired in Washington has noted that it's probably going to be likely next year, the following year, sometime in the near future, where EPDs are going to be required for our products, if not all products. So just keep that in mind if you're selling treated wood into the state of Washington, or if you're a treater in the state of Washington, that this is something that's going to be coming down the pike. I wouldn't be too worried about it. We do have a great story to tell, especially when compared to steel and concrete, which I think is going to take a really big hit. We do have a great environmental impact and a life cycle assessment. So this isn't something we should be fearing, other than the work putting in to get it all squared away. But once it's all squared away, I think we have a great story to tell. And I think a lot of legislators and a lot of environmental justice folks are going to really see how important our products are. Moving on, we've got a few Neo-Niconatoid bills this year. I only have 4 up on the screen. California recently introduced a Neo-Niconatoid bill. Thankfully, that bill in California only applies to seeds, so it does not impact treated wood. But in Arizona, there were 3 Neo-Niconatoid bills that were introduced. SB 1201 was an all-out ban on 4 neonicotinoids, one of them being imidacloprid, which we use in our preservatives. And the other 2 were a ban on neonicotinoids with some exemptions. SB 1275 had an exemption that included our industry, and we've been working with the author to fine-tune that exemption to broaden it to all treated wood, not just pressure-treated wood. And then HB 2093, speaking with the author, they were open to amending their bill to mirror 1275. However, I don't think any of those 3 bills are moving because they're Democratic authors and the House is controlled, or the legislature is controlled by Republicans. So I think if they don't move by Friday, they're dead bills. We've got New Mexico has a Neo-Niconatoid bill. It's a really lengthy bill compared to the others around the nation. And as the bill was introduced, it did have an exemption for treated wood or preserved wood. And we've been working with them to fine tune this bill to expand to not just pressure treated wood, but to all wood. And also we've been trying to advocate to them that the Department of Agriculture should be required to allow this exemption. Currently, the bill, while it has an exemption for treated wood and hair care products and pet products, it's only contingent on if the Department of Agriculture allows it. Our ask for the Department of Agriculture to be required to make this exemption has been echoed by other industries, but it doesn't seem as if the author of the bill has been open to that idea. So I'll keep you all posted on that, and let me know if you have any concerns with those 4 or 5 bills. I believe that is the end of this presentation. Really appreciate Lonza for letting me speak to y'all. Hope you're not asleep for the rest of it, because I know it was pretty dense and boring. You've got my email address and my cell phone up there. Feel free to give me a call or shoot me an email if you want any information regarding the webinar that's taking place on Friday in California for the disposal of treated wood waste. Thank you all. I appreciate it.
Ryan, I have one question.
Yeah.
Someone wants to know, who is Hampton?
They're opposed to the bill in Washington. So like a few of the wood industry folks, whether they're growers or lumber mills, have been against the environmental product declaration. So they're one of the entities that were opposed to it, with I think the other one was Washington Forest Protection Association.
Okay, thank you.
Brian, this is Terry Mocco. I have a question regarding that, the Washington, you said the EDP, in revealing what, for example, composite wood is made of. If wood preservatives are used in the engineered wood, would we then be required to reveal our composition of the complete composition of our wood preservative to the individuals that are then selling the wood, because they have to know everything that's in there?
I don't think you have to give the composition. Hold up, let me bring up, because I'm looking at it right now. It's pretty much asking for so EPDs are created through an internationally recognized standards by third party verified, and they look at different things on the impacts of the environment. So I don't know if you have to, at this point in time, disclose the ingredients or the confidentiality of what makes those composites at this point in time, but there is some issues with the reporting in the bill, and that's where the 2 entities I noted raised concerns, is that they're asking for a bunch of stuff that doesn't really apply. Most of the things that they're asking for, given that these are public works projects, are number of employees, hourly wages, things of that extent. But I can keep a note in regards to the product engineering of the composite materials.
Thank you. Yeah, that would be good to know if there would be potentially we would have to reveal our, the composition of our preservatives.
All right, I'll look into that. Thank you for bringing that to my attention, Terry. Any other questions?
I don't see anything come up, Ryan. Thank you.
And then I didn't see anybody's hands go up, but did anybody's hands go up for any of the things I asked?
I looked each time you asked that question. I didn't see any hands
All right,
go up when
thank
you
you.
asked the questions.
Appreciate it. Thank you all. Grady, appreciate it. Take care.
Thank you, Ron. You take care also. Our next speaker is Terry Mocco, and she joined Lonza in 2014 and now serves as Senior Manager of Regulatory Affairs, Americas. Terry has nearly 30 years of regulatory experience with wood preservers. Her responsibilities including securing and managing pesticide registrations in the Americas and ensuing compliance with all applicable pesticide regulations in these regions. Terry is a longtime participant of the American Chemistry Council, Biocides Panel, and Panel Task Forces. Terry is chair of the Arsenical Wood Preservers Task Force and an active member of the Antimicrobial Exposure Assessment Task Force 2 and the Copper Task Force. Terry has a Bachelor of Arts degree from State University of New York in Communications and Political Science. Terry will be talking to us about pesticide labeling. Welcome, Terry.
Thank you, Grady. Good afternoon. Hope everyone's having a good day here. My topic will be pesticide labeling, something I know you guys just can't wait to hear more about. So pesticide labeling, and why is that important? Anyone who applies a pesticide should understand that pesticide label. And I'm not just talking about the pesticide labels that are on the products that you use at work, but also consider the number of pesticides that you may use in and around your home. So it's very important to understand the labels, and that is what we're going to talk about today is, what is a pesticide label? What are the types of labels? What's the difference between label and labeling? How are label requirements regulated, and why labeling is so important, and why it's important to read and follow the label. Labels and labeling. Pesticide label would be what you typically think of when you see a label on a tote or on a drum or on some type of super sack of the product you receive, or if you are getting product delivered by bulk tank trucks, that the driver should be leaving each time he delivers your product a copy of the product label that's associated with the material that you're receiving. Labeling, on the other hand, includes the label as well as any written material that accompanies the product label. For example, some type of brochure. Sometimes in a store you may see, because especially if you have a small bottle or container, the labeling may actually be some type of little tag that's attached to the container, or you'll see pull-out type labeling on a container, or I know agricultural products, so those labels can be multiple pages long. You could have a 20-page agricultural label, and so that would come in a booklet that is associated with the label that's actually on the package. And labeling is regulated by EPA in addition to what we consider the label. So EPA is the government agency that regulates pesticides and reviews every pesticide product and approves that product. Registrants, you'll hear people refer to registrants, and they're the companies that have registered any pesticide with US EPA. compliance with the Federal Insecticide, Fungicide, and Rodenticide Act, or FIFRA, how it's referred to it. And pesticide registration is the process in which EPA will examine the ingredients of your pesticide, where it's going to be used, what site, what's the use, the crop, if it's an agricultural product. They look at the amount, the frequency, the timing, the application rates that are going to be used. They look at the testing data that shows that potential health and environmental effects of the use of that product. They, in some cases, look at the efficacy. If it's against public health pests, such as termites, they'll look at the efficacy data for that, and how you plan to recommend the storage and disposal of that product. Now, they evaluate the pesticide to make sure that it's not going to have any unreasonable adverse effects on humans, the environment, and non-target species. Pesticides have to be registered with EPA before they can be sold or distributed in the U.S., and then each individual state also requires a registration to be used or distributed in that state. There's also, I think we're up to about 10 states now too that require registration just if your product is going to be passing through the state. So for example, we have a bulk truck that is carrying a pesticide product, and he's traveling from point A to B, and not only does he have to be registered in those states, there may be certain states in between that we have to get up registrations for just because we are driving through the state with that product. So what happens before you see the pesticide label, before it's on the product in your place of business, or even in your home? Manufacturers have to conduct tests, and we have to go in with our application to EPA with data, and that data includes toxicity or toxicological tests, because that's going to tell EPA how poisonous that product is to humans, to wildlife, to non-target organisms. We have to go in with product chemistry data. EPA wants us to tell them how we're going to make the product, everything that's going into the product in terms of composition. They want to know physical and chemical characteristics of the product. They want to know the pH. They want to know the density, solubility. There's a whole storage stability over a long period of time, corrosion. Those are the type of product chemistry tests that we provide EPA. Efficacy and performance tests are required for products making public health claims. And for example, a disinfectant or sanitizer, something that's going to affect the public health. But in terms of wood preservation, we only need to provide EPA with efficacy data if it is we are making a claim of termite protection, because they consider that a public health claim. If we're only making a claim for decay, we do not need to provide EPA with efficacy data to review, because they feel that the market will determine whether the product is successful or not. The state of California does require efficacy data for all claims made on the label. If you are located in the state of California and you look at a product label, you will often see if the label has, say, 10 different types of uses or use sites on that label, there may be a number of them that say not for use, not in the state of California, because a registrant may have only supplied efficacy data for a subset of those uses on the label, and so not all uses may be open for use in the state of California if the registrant hasn't supported it with efficacy data. Other data supplied to EPA is degradation and mobility and residue type data. For example, they want to know what happens when the pesticide gets into the environment. They want to know what happens after it's applied. Does it leach from wood? That's very important. They need to, when it comes into environmental exposure, and does it dislodge through hand contact with the wood? And that's very important to know when it comes to human exposure. So EPA will take all this data, and then the proposed label, when I go in with an application for registration to EPA, I'm submitting the data, and I've drafted a label that I feel represents the data that I'm providing to the agency. And they are going to see if the product is accurately classified, all the active ingredients are listed, the target pests are identified, that the precautionary statements on the label reflect the hazards of the product. They'll look at the results of the test data and determine if I've accurately displayed what those hazards are on the label. They will review to make sure that the label clearly directs the user on how to apply the product and the amount of product to apply. And also, does the label I provided them direct the user on the proper disposal of unused product and what to do with the pesticide container once they are done using the product. So for all these reasons, it's important for you to read the label before you buy the pesticide, because you want to make sure you're buying the pesticide product that is going to do the job that you want it to do, is labeled for the uses that you want and for the locations that you want to use the product. You need to read the label because before you store it, to make sure that you're storing it correctly. That you, for example, there may be storage precautions in regards to storing, maybe the product is potentially flammable, so there may be storage instructions in regards to that. Maybe it is affected by an oxidizer, so you may need to separate out for where you're storing by other products. So it's important to read the label to make sure you're storing it correctly. You should read the label before mixing and applying the pesticide. You want to make sure that you're not mixing it with something that you shouldn't, that you're not mixing it incorrectly, especially concentrate products that need to be diluted. You want to make sure you're diluting them correctly and that you're applying them in the manner in which is allowed on the label. And then when it comes to disposing of the unused pesticide in the empty containers, you should have a plan for that. So you should be reading that label before you even buy the product. So you're set up to dispose of the pesticide in the containers correctly once you do purchase the product. So there's various parts to the label, and if you're buying our products, we use the same format for all our pesticide labels, which you can see here is an example of the Wilmanac concentrate 60% label. And some companies, now for us, the primary label is right in the center. Some companies may use it, have a format in which they consider the primary panel to be on the far left side of the label, and it reads across, but our labels are all set up. And this is the most common format that is used in terms of pesticide labeling. And the primary panel, the front panel on our labels is the center panel. And this is an example of the type of information that you'll find on the primary panel. And this is considered the most important information to EPA, and that's why it's on the primary panel. The restricted use statement. If a product is restricted use, and not all of our products are, but if it is, then that statement will be on the primary panel. You'll find the product name, the ingredient statement. There's a child hazard warning statement. All labels will have a child hazard warning statement. The signal word and skull and crossbones symbol and the word poison if required. And with a Wilmanac label, you'll see that it is on this label. The signal word is, and we'll get into that a little later, but it's, for example, on this label, it's danger. Your first aid statement is also right on the primary panel. And then this is also where we locate our net contents and our net weight. The restricted use statement. And as I mentioned, not all products are restricted use. At one time, EPA classified products, it was common to refer to restricted use or general use. They don't use the term general use anymore. It made it appear that people thought maybe products were safer if it was general use. So it's really, and that's not necessarily the case. It's either restricted use or not classified. If a pesticide's toxicity exceeds certain hazard criteria, then it is classified as a restricted use pesticide, or we refer to as RUPs. And they require a statement in a box on the top of the front panel with nothing above it. That's why it's going to be, if you have a restricted use product, they're always going to have that statement right on the primary panel at the very top. And the statement will include the following elements in this order. It's going to say restricted use pesticide, and then the reason, the restricted use classification. And in this case, for the Wilmanac product, it's due to acute toxicity because this product contains arsenic and chromium compounds. And then that's followed by a summary of the statement of terms of restriction, which is This product is not for retail sale and can only be used by certified applicators holding current state certification, which is the reason that most of you, I believe, are probably attending this seminar, is because of use of these products, restricted use products, and the requirements to be licensed to apply them. Under the restricted use, you'll normally find the product name. Just the thing I want to mention in regards to product names is EPA, if they feel that you're using a name that can be false and misleading, they will deny you the ability to use that name. They'll say, no, you got to pick a different name. And for example, safety oil is considered misleading because it implies a safety claim. I've seen them reject names that say plus because it makes it sound as if it's doing something more than more effective, perhaps, when it's not necessarily the case. So we have to be careful in how we choose our product names and to make sure that they would be acceptable to EPA. Also, you cannot have two pesticide products with the same name. You can have similar names, there's going to be a slight variation, but you cannot have two products with the same product name, two different products with the same product name. Also on the primary panel is your ingredient statement. Now it will identify the name and the percentages by weight of each active ingredient and the percentage by weight of the other inner ingredients. In the active ingredients are your chemicals that are going to be responsible for the pesticidal activity, or they're going to perform the function that you want that product to perform. Whereas the inner ingredients, which are not normally named, but we'll just put a total percentages for them. Now, just because they're listed as inert does not mean they're not hazardous. It just means that they do not have the pesticidal activity of the active ingredients, because you can have some solvents that are considered inner ingredients, but they are very hazardous. For example, you could have corrosive products such as MEA as a solvent, and that's still that's listed as an other ingredient. So you're just going to list your active ingredients, and in this case, we have the chromic acid, the cupric oxide, and the arsenic pentoxide. And then it's common for products containing metals to then give the metallic equivalent to those ingredients too on the label. Typically underneath your product name and your ingredient statement, it will say on a product label what it is. It may say insecticide, fungicide, and it potentially will say what the product is. It may say what pest it controls. There's usually a little, it's not required, but there's usually a little blurb right below the product name that describes what the product is. The warning statements that you'll find on the primary panel include, as we mentioned, the child hazard warning statement, which is your keep out of reach of children. And that's going to appear on almost all end-use pesticide products. And that's, you may think that's, that is a bit strange on a product that's used in an industrial setting, such as where we are working, but it is required on all pesticide products. You have your signal word, which is, again, a result of your acute toxicity studies that you submit to EPA. From the results of those studies, there's actually a whole table that you can look at and say, well, this is the result of this study, so I fall into this category. What you may have, for example, the results of your test may indicate that maybe 3 out of 6 tests are caution. You have 1 that's warning, and maybe 1 test comes out as danger. Your signal word on your label is going to be that, the most severe classification as a result of those toxicity tests. And then we have the toxicity category 1, 2, 3, and 4, which correspond to the danger, warning, caution. And tox category 4 is no signal word is required, although the agency does recommend that you use, they like you to use caution even if it's not required, it's recommended. And then for some certain ingredients, for example, methanol, is present in concentrations of 4% or more. The signal word, regardless of the toxicity categories, will be danger. So there are some exceptions to just following the guidelines for as a result of the tox test. There's some reasons why it may just be danger. And then also we have the skull and crossbones symbol and the word poison, which is on the Womack label. And that would be still tox category 1, but it's a higher level of a tox category 1 product. First aid statement, From the labels that we have prepared, our first aid statement is on the primary panel. There are some less hazardous products that would allow first aid statements to be on another panel, a side panel, but for our products, we have always formatted our labels to be first aid statement to be on the primary panel. It will provide you information on the user concerning the appropriate first aid for various routes of exposure associated with the accidental exposure. For example, if you get it in your eyes or on your skin or inhalation, it gives you advice on what you should do in order to react to that type of exposure. I will say it's always good, especially our products, which you're using in the plant and you have them in bulk storage tanks, and it's not like you can, if there is an emergency, you can't just, for example, grab a can, take it with you to the emergency room and say, this is what the person was exposed to. So you should always have copies of those labels readily available. So in the event of emergency, if you have to call someone and explain to them what an individual is exposed to, or if the person needs to go seek medical attention, that they should have a copy of that label available to take with them. So it's always a good practice to have them in a location that they can be easily accessed. The net contents or net weight section will identify the weight of the volume of the pesticide in that container. The net contents must be expressed in U.S. measurements. Any metric measurements they can be included, but in parentheses next to the U.S. measurements. Also, the net content should be in the largest suitable units. For example, 1 pound, 10 ounces rather than 26 ounces. And net contents for a pesticide product has to be consistent with the directions for use. The label directions for use should not require a quantity of pesticide product to be applied that exceeds the net contents or net weight of the package. So, if you're telling someone to apply 1 pound of material, you can't sell them a half pound container. Also on the front panel, you'll find your name and address of the manufacturer, the EPA registration number, which identifies that particular product, and the EPA establishment number. For Archwood Protection Inc., our EPA company number is 62190. So whenever you see 62190, that refers to Archwood Protection Inc. Here with the product registration number, 14 refers to our product number. The establishment number shows you that that's Archwood Protection Inc. in Georgia. And the one identifies, we only have the one facility in Georgia. If we had multiple facilities, manufacturing facilities in Georgia, then it would be either the GA-2 or 3, depending on how many facilities you have. And this is true for all your pesticide products. If there's ever a problem, this allows EPA to trace back to where that product was last produced. And in production would be whether it was labeled, repackaged, or actually formulated. But the last place it was produced, so the place where that product was packaged and labeled prior to distribution to the end user, that's whose establishment number will be on that label. So parts of the back or the side panels of the pesticide label, most notably is you need to read your precautionary statements, because they're going to provide you with information regarding the toxicity, irritation, sensitization hazards associated with the use of pesticides, as well as treatment instructions and information to reduce the exposure potential. You're going to see right at the top is a statement that says hazards to humans and domestic animals, and then you're going to be giving precautionary statements in terms of hazards due to route of exposure, the precautions that you should take. It will be on the label, and including what PPE should be worn. There'll also be an environmental hazard statement. For example, it may say whether or not that product is toxic to fish and wildlife. It will give you that type of warning on the statement, as well as, and not all labels have physical or chemical hazard statements, but if there was a hazard that exists, such as flammability or explosive potential, there will be a physical or chemical hazard statement on the label. And this is just an example of what a precautionary statement would look like on a label. You have your hazards to humans and domestic animals. You'll have your signal word repeated. It's on your primary panel, then it's again here by your precautionary statements. In this example, this product is fatal if swallowed, maybe fatal if inhaled, harmful if absorbed through the skin. So it's giving you the hazards, and then it's telling you, do not breathe dust or spray mist. Avoid contact with skin, eyes, or clothing. It's telling you ways to avoid exposure. Wash thoroughly with soap and water after handling and before eating, drinking, or using tobacco. Then it tells you what PPE should be worn. And in this example, it actually breaks it up between mixers and loaders, and it tells you what a mixer and loader should wear, and then what an applicator should wear. And it's going to be, there are other labels that have even broke down even more by the various tasks which an individual performs, and that's to make sure that that individual is protected for those tasks. And this is the PPE that's currently on the Woolmanac label. It is important for the user to read this and to follow the PPE that is on the label. And just to give you some information on how this list of personal protective equipment comes about, is EPA conducts a risk assessment. And we have over the years done a number of exposure monitoring studies within a treatment plant. Grady had mentioned that I participate in the Antimicrobial Exposure Assessment Task Force. And what that task force does is come up with measures of exposure by an individual is applying pesticide products. And we went into treatment plants and we did monitoring to determine with all the various tasks, what are the levels of exposure for those tasks. And then EPA takes that information and then they look at tox data and they look at other information they have and they determine where do the risks exist, what job functions have what risk, what needs to be done to mitigate those risks. And that is what really goes into the PPE that's on a product label. So the reasons we're saying, you know, wear the gloves or wear the long sleeve shirt, or if in any of the instances we want you to wear some type of ventilator, or excuse me, some type of protection for inhalation, that is because we've determined that there is a risk of exposure. And so what we've done is we've told the agency, well, there may be a risk, but if they do this, then that will mitigate that risk. And that's how we, as the registrants, work with the agency to continue to allow these products to be used. Is, you know, we understand that, yeah, risk may occur. And so what can we do to make sure that as the applicators and the users of these products, you are protected? And that's why the PPE is on the labels that they are, and that we really, really urge you to read these labels, be familiar with the PPE, and follow what they say. This is an example of some environmental hazard statements that you may find on a label. And you'll see that the B caution, that is something I think you're going to see more and more on various products, not necessarily our wood preservative products, but as you look at pesticide products that you use around your home, because EPA is very much focused, and as Ryan was mentioned earlier, that neonicotinoids is definitely an issue that is being looked at by all our state environmental agencies, and it's a hot topic right now. So the directions for use section of the label will provide instructions on how to use the product. It will tell you the method of application. For example, it will say on our products that to apply by pressure treatment. Sometimes we do have products that can be applied by pressure and surface applied, and that, for example, by either you dip or spray. And if that's the case, it will say that on the label. It will tell you what pests that will be controlled by the use of that product, how to mix and apply the product. It will tell you if it needs to be diluted, you know, at what level should it be diluted. What process controls, especially with the Woolmanac label, there are many controls that need to be in place when using that product, and they are stated on the label. Also, how to handle the wood after treatment. There are a lot of labels that that go into where the wood should be stored, staying on the drip pad until no longer dripping, or there are some products that may require covering of the wood after treatment for a certain period of time. That would all be spelled out on the label. The directions for use include the following elements: the directions for use heading, and if it is restricted use, that would be right underneath that heading. Again, it would be a state restricted use. Every pesticide label is going to have the statement, it's a violation of federal law to use this product in a manner inconsistent with its labeling. And that's very important because that's what we refer to as the label as the law. That's telling you that that label, if it's not followed, is a violation of FIFRA, and you can be found liable for misuse of that product. Application directions, subheading. The section may include information how the product works, give your directions, use sites pass, and then your use restriction statement. So that order, all pesticide labels are to be written in that manner. And this, definitely not reading through this, and it may be a bit small to read, but this was just to give you an example of what the size of the directions for use for the Wilmanite concentrate 60% label, and that's because of the detail that it goes into for engineering controls, and a lot of other aspects in terms of what to do in terms of ventilating the cylinder after charges. So it is a lot of detail in it. As I mentioned, there are some agricultural products whose directions for use are multiple pages. Storage and disposal instructions are always to be on under the same main heading of directions for use. That's going to tell you on proper storing, as I mentioned, the pesticide product, how to dispose of unused pesticides. There'll be container handling statements. There'll be instructions for telling you how to, if it wants you to triple rinse, we have to have instructions for telling you how to do that triple rinsing. In the storage and disposal section may have instructions how to dispose of the rinsate also, especially when you're triple rinsing. And then there may be instructions if it's a refillable, it'll tell you if the container is refillable or non-refillable. And if it is, you can refill it, it will have some additional directions on that too. So it's a very important section to read. As I mentioned, the label's the law. Unlike most other products, pesticide labels are legally enforceable. And that's why they all carry that statement that it's a violation of federal law to use it in a manner that's inconsistent with its labeling. Enforcement of pesticide regulations and label requirements is primarily carried out by state agencies acting under agreements with EPA. So state agencies they're going to be the ones that are going to show up at your door and want to do an inspection as opposed to US EPA representatives. Some examples of label non-compliance would be applying to a site not stated on the label. I'm familiar with some state inspectors actually looking at charge reports and at the levels of product that were applied to see if the rate of application was consistent with the labeling. And also mishandling, they'll see if it's, where your product is being stored. And again, they want to ensure if they were to come on your site that your product is being used and consistent with what was on the product label. So that's why it's important to know your label, and as all these offenses are punishable by law. So in summary, just follow your label directions carefully, read the label before you buy it, mix, apply, store, and dispose of the product. Be familiar with names, signal words, and symbols for the products that you use. Know the use instructions, be aware of the precautions, protect yourself, follow the PPE requirements, because it's the applicator's responsibility, the individual that is using the product, to know and be familiar with that label for the product that they're using. Any questions?
I don't see any questions that have come in, Terry. Thank you.
Sure.
Thank you, Terry. I don't see any questions here either. Well, thank you very much.
Okay.
Okay, next up is going to be Michael Collins to talk to us about PPE requirements. Michael is Senior Specialist, Environmental Affairs and Product Safety for Lonza. He has held this or a similar position since his hire in 2006. In this role, Michael provides EH&S support to Lonza's customer base and also has responsibilities for developing and maintaining SDSs for Lonza wood protection products. Prior to Lonza, Michael served 2 years with MacTech as an environmental consultant and 10 years with the Chemical Waste Management as the Southeast Region EH&S Manager. He is a U.S. Navy veteran and a graduate of Auburn University with a Bachelor of Science degree in Environmental Science. Welcome, Michael.
Thanks, Grady. I appreciate that. And welcome everyone to the West Coast seminar. I hope you feel the same as I do. I can't wait to have these in person again. I miss the conversations and being able to see everyone and catch up with you in person. So I look forward to those days. But this presentation on PPE is really designed to allow you to think about what the specific PPE is designed for and allow you to hopefully help choose the most appropriate one for what you're trying to protect yourself from or your employees from. So in general, I'm just going to discuss hard hats, eye and face protection, respiratory, hand and foot protection. And this is a very broad overview, so you're not going to learn everything you would need to know, but I'm always available for questions, specific cases, happy to help you select specific materials or help with any questions that might allow you to protect the appropriate PPE in your own workplaces. First, starting with hard hats, there are 3 basic types of hard hats that you can choose that are on the marketplace, and it's important to know what each one does to make sure you you choose the right one to protect yourself. Class G is a general hard hat. It protects against impact and penetration, also provides low voltage protection up to 2,200 volts. Class E is considered an electrical protective hard hat. It's designed for electrical and utility work, and it also protects against falling objects or impacts, and it has higher electrical protection up to 20,000 volts. Class C is a conductive hard hat. You often hear these referred to as bump caps. They're really designed just for comfort. They're very limited in terms of the protection they offer, only protect against small bumps. They don't really protect the user from falling objects or electrical hazards. So you want to make sure that you're choosing the right one for the type of work you're doing. Safety glasses versus safety goggles. Again, here it's important to understand what the difference is and make sure you're using the right one for the right job. Safety glasses protect the eyes against moderate impacts from particles, whereas safety goggles actually protect your eyes and facial area from impact, dust, or splash. Glasses provide very minimal protection for splash hazards. So if there's any kind of splash hazard involved, you really want to make sure you're using safety goggles or some other type of protection other than just safety glasses. A face shield protects the face from nuisance dust and potential splashes or sprays. However, they're not eye protection. To protect the eyes, you should wear safety glasses or goggles under the face shield. So if you're working with any type of hazardous liquid that's a corrosive material, you do not want to use a face shield only. The main 2 types of respirators that are on the marketplace, there are others, but the 2 primary ones are either air purifying or supplied air. Air purifying actually removes contaminants from the air using some type of filtering device. Whereas supplied air respirators provide clean, breathable air to the user, so likely there's some sort of tank that the user is carrying around to actually pump air to the user. In either one of these cases, the facility has to have a written respiratory protection program, and the users have to be medically evaluated and fit tested prior to using the respirator. An individual cannot just put on a respirator and use it in the workplace. They have to be used in conjunction with a program and medical and fit tests. There's several kind of gloves on the marketplace. Here it's important to look at what the glove is protecting or is supposed to protect the user from, and then make sure you select the right material. Here's a few examples. Anti-vibration gloves, chemical resistant gloves, probably the most common type of users. There's leather gloves, permeation resistant gloves, heat resistant, and cut resistant. Here again, it's important to select the right type of material for the work you're doing. Work boots, they're required in areas where there's a danger of either foot injuries due to falling or rolling objects. These type of work boots generally have a metal toe cap to protect against falling or rolling objects. And most of them will have rubber soles to protect against chemical materials. And in fact, Terry was talking about some of the requirements for PPE on some of our labels. And specifically, our CCA label actually does require rubber soles on the shoes. So it's just another thing for you to check to make sure you're using the right type of PPE if using that chemical. Again, there's several types of full body protection available. I've listed some examples here. But again, it's important to understand what the material protects you from. A laboratory coat is kind of the white coat you see in labs. It offers minimal chemical protection. It offers some protection, but not any long-term protection against most corrosive chemicals. Some coveralls differ by the type of material they're made out of. Vests, jackets, aprons, full body suits. Again, you have to understand what materials you're working with and then select the appropriate material and type of body protection for the job you're doing. Again, we've talked about the EPA label and the PPE protection requirements on the label itself, but many of you, I'm sure, are familiar with the SDS, the safety data sheets that are also available for the products. They also list PPE requirements, but those on the SDS are more recommendations. The ones on the label are required by law. So if there's any difference between the two, you want to make sure you follow what is required on the label. For most unregistered products, these are the additives, water repellents, and so forth, the SDS is where you would want to look for that, and is also the label there. But it's always important to read and follow all the label instructions provided. Here is an example of our CAC label, and you'll see that the PPE requirements are on the left panel here. Coveralls over long sleeves, shirt and long pants, socks, chemical resistant footwear, goggles or face shield, chemical resistant gloves, and also when mixing and loading, a chemical resistant apron. Every one of you should, if you're working with any of the chemicals, read the specific label and make sure you're following the label that is, the PP requirements that are on the specific label for the product. I didn't list all the other products, but do go and look at each one of the different labels for the products. And when choosing the materials for the different types of PPE, whether it's gloves, full body wear, OSHA does make available this guide that's really useful to help you select specific material types for different jobs, depending on what the material is. So for example, if you're working with diesel fuel, you'll see that neoprene, if you look down here, neoprene is considered good for working with diesel fuel. Latex rubber is considered poor, as is butyl, and nitrile is considered very good. So that's just an example where you can choose a specific material and then go look up what type of material OSHA recommends for working with that hazard. I can provide that to you. OSHA also has it on their website. But for any of our chemicals, you know, I'm always a call or an email away if you want to help selecting any specific materials for any of our chemicals. Copies of the OSHA guide are available. Always also keep in mind that what is listed on the product label is considered minimum PPE. You have to at least use that minimal PPE that's required. And I and our sales reps are available for any help you might need. And that's the end of that presentation. Any questions?
No questions, Michael. Thank you.
Thanks, Sarah.
Thanks, Michael. Belinda, where's the next slide? There we go. We're going to continue with Michael speaking about hazardous waste management, and then following Michael, we'll go into a 15-minute break. Thanks, Mike.
Sure. All right, so lucky y'all, you get me again for a quick hazardous waste management session. And during this, I'm going to cover several different areas of hazardous waste requirements. And Belinda, I cannot get the slide to advance.
Sorry, okay, let's try it again. Hold on. Trying it?
Yeah, no luck.
No, all right. I'll do it for.
Okay, thank you. I'll just say next. All right, so these are the areas I'm going to cover during the presentation. First, an overview of what the different requirements are, but then more importantly, perhaps, what you actually have to do to comply with those requirements. And they're broken out into areas including accumulation, inspections, programs, and reporting. And also, I'm going to briefly cover the generator improvements rule. This is a new rule that has been in effect for a few years. Most states are slowly starting to adopt it. So we'll talk about where it's been adopted, what it means, and as we're going through the presentation, when new requirements of this particular rule are mentioned, they're highlighted in green. So if I make a reference to anything required by this rule, it'll be in green. I will give you a heads up. I'm sure users in the states are aware. I don't believe California has adopted the rule. And I believe that Oregon also has not, and Washington has, although I might have that backwards. But the last slide is a map that does indicate what states have approved it. So again, we'll address that at the end. It's important to understand what those requirements are because it is a significant rule. It does have a lot of new requirements, and when it goes into effect, in general, you'll be required to comply immediately. Okay, so here's the general requirements for generators. And this is important to understand because most of the requirements for generators are based on how much waste is actually generated per month. So it's always important to understand and follow the requirements of your category. And if your category changes from month to month, then you have to follow the requirements of the class you're in for that month. A very small quantity generator is one that generates less than 220 pounds in a month. And here you see that the name, very small quantity generator, is highlighted in green. Previously, this was known as a conditionally exempt small quantity generator. So really, in effect, the only change here is what they're called. There are a few other requirements that change, but for the most part, it's the name. The next category, which if you generate more than 220 but less than 2,200 pounds of waste in a month, then you're considered a small quantity generator. And if you generate greater than 2,200 pounds in a calendar month, you're a large quantity generator, which means you have to follow all the requirements. Next. So those are the generator requirements, but since you treat with regulated chemicals, you're also subject to what's called Subpart W standards. These are standards that other generators in the industry wouldn't be required to comply with. Only drip pads are subject to Subpart W standards. And if you use a preservative that contains arsenic, then your waste from that drip pad is considered F035. Creosote has its own waste code, as does Penta. So F035 is specific to arsenicals. Next. So when you ship your hazardous waste off-site, or any hazardous waste off-site, there are a few common disposal methods available for waste. If the material has a high BTU value and it can be used as a fuel, it likely probably will be used as a fuel. So they'll ship it and then they'll recycle it, maybe purify it, distill it down for energy recovery and use it as a fuel. Unfortunately, that's not an option for drip pad waste. One option that is available is incineration. So the waste would go to a hazardous waste incinerator for just burning. That often is higher cost. In general, it's higher to dispose of waste via incineration. Another option is underground injection. This is not an option for drip pad waste since it's a solid. This is typically liquids that the facility might inject deep into the subsurface of the soils, thousands of feet underground. Of course, it's highly regulated and needs a permit from the EPA to do that. But there are some facilities that do that type of disposal. By far the most common disposal method is landfill. This is where the waste is typically treated some sort of way to bind it or to solidify it. In the case of FO35 waste, it is usually binded using cement to reduce the leachability of metals, and then it's placed in the landfill for disposal. Most of this waste, at least in the East Coast, is disposed at a landfill in Alabama, a chemical waste management landfill in Alabama. In the West Coast, I imagine most of it goes to the Kettleman facility in Central California. I'd be interested to hear if there are other landfills that it goes to. Those are the two I know of that generally accept the waste. Next. All right, so this is kind of an overview of the two types of accumulation. There's what's considered central accumulation, and then there's what's considered satellite accumulation. And there's some significant differences between the two. Washington, those people in Washington can ignore the satellite accumulation as it applies to your drip pad. If you were listening to Ryan earlier, you'll see that Washington doesn't recognize the satellite allowances for drip pad waste. So I imagine you could still use satellite for other types of waste at your facility, so maybe it's important to understand, but not for drip pad waste. Next. So for central accumulation, here are the minimum requirements you have to comply with. The drums have to have a hazardous waste label. The drum must remain closed at all times, except when you're adding or removing waste. Obviously, it can be opened then. But as soon as someone stops putting waste in it, it needs to be closed. Drums have to have an accumulation start date. That's the date that you first started putting waste in the container. And drums also have to identify the hazards of the waste. You'll see that this is in green. This is a new requirement of the generator improvements rule. You can meet this requirement several different ways. I tend to think the easiest way to meet it is go ahead and apply the DOT placard. When the waste is shipped, it has to have that on it anyway. So drip pad waste is class 9, so it would be a class 9 placard. You just go ahead and affix that to the drum as soon as you put waste in it, and you'll meet this requirement. And then you also are not allowed to exceed the storage time restrictions. Large quantity generators can store their waste for 90 days on site. Small quantity generators are allowed 180 days. Next. So that was central accumulation. For satellite, it's very similar, but the main difference is there's no time restriction. So you're allowed to store the waste until you accumulate 55 gallons. But the drum must be closed. You can't exceed that 55 gallons. It also has to be at or near the point of generation. That's a requirement that doesn't apply to central, but does apply to satellite. In other words, wherever you're generating that waste, that's the only place you can have a satellite drum for it. The drum has to be labeled with the words hazardous waste and also must identify the contents. Use a DOT placard, that's the easiest way. And then once full, you'll add the start date to the label and move the container to the central accumulation area within 3 days. So that is a requirement. You have to move it to the central accumulation area within 3 days. Next. All right, so here's an overview of some of the inspections you have to do. There are a lot of them. There are drip pad inspections, sump inspections, inspections of the containers, cease drippage records, and drip pad certification. Next. So the drip pad has to be inspected every week and after storms if it's not covered. You have to inspect it for deterioration, any type of malfunction or improper operation of the runoff and run-on systems. You know, these are the berms or whatever you use to prevent runoff or run-on the drip pad. You have to make sure that they're operating properly. If you have a leak detection system, you have to make sure that it's operating properly. And you have to check the surface of the drip pad, looking for cracks or any type of obvious deterioration. What you're looking for here is anything that might allow leakage to occur underneath the drip pad. I'll also note that I've added the regulatory citations at the bottom of each of the slides, so that if you ever wanted to go back and verify any of the requirements, you can go back directly to the regulations or you can call me. Either one's fine. Next. Subpart J for sumps. They have to be inspected daily for large quantity generators and weekly for small. So if you're a small quantity generator, sure, you can do them daily, but you have to do them at least once a week. Here you're inspecting the sumps or the pits to make sure that the pumps operate properly. You know, you want to make sure that if there's a spill or an overflow that the pumps are working, so they want you to check them. In general, that means actually turning them on, make sure they operate. The second requirement is to check for indications of corrosion or release. And similar to the drip pad, here you're looking for cracks or gaps or other issues that might lead to drippage from the sump. And then you're also inspecting the secondary containment area, that area underneath the sump, to make sure that there hasn't been leakage. All right, next. Hazardous waste containers have to be inspected once a week. You have to inspect each container for proper labeling, which would include the words hazardous waste. You have to make sure it has an accumulation start date, that the hazards are identified. You know, that's, in this case, the DOT placard, if that's the way you're identifying the hazards. And you're also inspecting it to make sure the drum is closed and that the container is in good condition. In other words, it's not leaking, there's not signs of significant rust that could lead to a leak or a spill. And I should also note that if any of these things are found to be deficient, you are required to make a note in your inspection log and say that the accumulation start date was missing and it's been added on such and such date. You're required to actually document the correction if there is a deficiency. You can't just say that the hazardous waste label is missing. If you do that and you don't show correction, then if an agency is looking at your records, it is going to probably be a violation. So, you know, it's fine to note that there's an issue and then note that it's been corrected. And that actually looks better to an inspector than if no issues are ever found. Because if no issues are ever found, then they might think that someone is not doing proper inspections. So that's just something for you to think about. Next. Also, you're required to inspect each charge that is on the drip pad for drippage before it's moved. So you are required to inspect and document that it's not dripping before it leaves the drip pad. This primarily only applies to CCA or ACZA. It's not generally required for copper-based preservatives, but it is required for the arsenicals. And these records can be written or electronic. There is a section in the application that allows you to check it in TreatRight, or you can actually have it checked off on a piece of paper. Either way, but you have to have a record for each charge. Next. The drip pad also has to be certified. It's required obviously initially when it goes into service, but then it's also required to be inspected by a professional engineer once a year. If the drip pad has a leak detection system, then that's not required, but if it doesn't, it's required to be inspected once a year. Here the engineer is looking to make sure that the drip pad is still operating as it was designed, and that there's no significant deterioration, and that it still meets all the requirements of subpart W. And I will note that for all the inspections that are included here, we do have template forms that are available. So if you want a copy of our template form, just give me a call and I can send it to you by email. Next, plans and programs. Here you basically see a green slide. So historically, you have been required to have a contingency plan if you're a large quantity generator. What has changed is that now you're required in the beginning of the contingency plan to have a quick reference guide. And these are all the elements that are required to be in that quick reference guide. Basically, what this amounts to is one page in the front of the plan where you identify all these specific items. I'm not going to read through them all, but it is kind of significant. It is a lot of information you'll have to add, or, I mean, it all should be in the contingency plan, but it's now required all to be right in the front. And I should also mention that when you update your plan, make sure you submit it to all your agencies. You know, any changes to your contingency plan has to go back out to the fire, the hospital, and emergency responding agencies. So when this goes into effect and you make this change, do make sure you update all the agencies. The way that I understand the update is required is that when you are required to update your plan for any other reason, then that is the time you're required to update your plan with this information. In other words, you don't have to just immediately do it, but you are required to do it if you're required to update the plan for any other reason. Next. You're also required to have a storage charge drippage plan and a plant operating history, which details what preservatives have used, how long the treating plant's been in operation. These should be on file at your facility. Let me know if you need help with either one of those. I've got templates that you can use to develop them. And also you're required to have training for all your individuals in your treating plant that work with hazardous waste. That training is required annually. This training for you can comply with that. You just have to make sure that you have it in your training file and that you have a copy of the training signature page and the presentation to go along with it, and I can help you if you need copies of either of those. But for those people that aren't attending the class, you want to make sure that they've had their training each year. Next. All right, a little mention about reporting. Large quantity generators are required to submit a biannual report. This is an annual report that details how much waste you generated it, who shipped it off-site, where you shipped it to, what treating facility. It's not difficult for the most part for generators, but it is required. Some states do require it once a year, but EPA only requires it once every other year. Also, manifest exceptions. These are interesting reports that, so when you ship hazardous waste off-site, you sign it as the generator, or someone at your facility signs as the generator. The transporter signs it that they've picked it up. Then the waste is shipped over to the final disposal facility. They sign it that they've received it, and they mail a copy of that manifest back to you. You're required to report to the state or EPA if you have not received a copy of that signed manifest. So if you haven't received a copy of that signed TSD manifest within 45 days as a large quantity generator, you're required to report that to the state or EPA. It's 60 days for a small quantity generator. But I would advise that you have someone actually tracking all the manifests And before that deadline, 45 or 60 days comes along, that you have contacted the treatment facility and you've got a copy of the manifest, whether they fax it to you or mail it to you or just send you an image on email, that you've got a copy of it. So what I would want you to do is go back and look at all the manifests you've shipped in the last year and make sure you've got a copy of the TSD signed manifest right with it. They know that copy should just go back right with the manifest. For spill reporting, you have to report if you have a spill over RQ levels. They vary by chemicals. It's 1 pound for arsenic. So it's pretty low for the arsenicals. Each of our chemicals has a spill poster associated with it, and those posters have the amount of RQ on them. Or you can call me and I'll give you the levels for each one of the chemicals. But it's important that you know what they are so that when you have a spill, you'll know if you need to report that to CERCLA. Here's a new requirement for small quantity generators. Every 4 years, you have to notify the agency that you're still a generator. And they're requiring this on the 8712, which is the EPA identification form that you submit when you first identify yourself as a generator. But now you have to notify them September 1st, every 4 years, that you are still a generator. And 2021 is actually the first year you're required to do this. So for those states where this law is in effect, this is a reporting year. So I would advise you to go ahead and get a copy of your state or EPA 8712, fill it out, and go ahead and submit it before September 1st. Next. All right, so here are just some other various things about the generator improvements rule. So we've talked about some of the elements, as we went through, but here's some new things that I want you to think about. Episodic generation has been around for a long time, and it's been managed through EPA interpretation and letters, and the agency's never fully defined it in the regulations until now. And what it does is allow a very small quantity generator or a small quantity generator to stay that status if they go over the threshold for the next level. So, let's say you're a small quantity generator and you clean out your tanks 1 month, and that amount would send you into a large quantity generator status. But that's the only reason that you're going into that. Well, under the new rule, you can stay small quantity generator without having to go back and forth. But you are required to notify the state at least 30 days prior to that event. And if, for example, you have a spill and you have to do a cleanup and that sends you over the threshold, then you have 72 hours after that event. So for a planned event, you have 30 days prior to notify. For an unplanned event, you have 72 hours after the event. So, it is a little bit of flexibility, but you've got to make sure you follow those notification requirements if you plan to take use of the allowance. Next. That's just one example of some of the changes. There are over 60 changes to the regulations. They are pretty significant. Here's a link to the fact sheet that kind of gives a summary of all of them. But I do think it's important for those people responsible for implementing hazardous waste requirements that you go through them, read the entire text of the rule, and specifically see how your states adopted the rule. I know some states are adopting things differently than other states. So, it's important to understand what EPA is saying, but it's also important to follow how your state implements the rule. And if they add any additional requirements to it. Next. Here's the map I was referring to earlier. Washington actually has adopted the rule. Oregon and California have not. Montana has not. Texas. So if it's in yellow, those are the states that have not adopted it. In blue are the states that have. And the green states are actually states that they're authorized by EPA. So when EPA promulgates new rules, they just immediately go into effect. So There's a few states that do it that way, but so that's the status of each one of the states. I checked this morning to see if this had been updated or changed by EPA, and it still seems to be what EPA thinks is happening. So this is a page on EPA's website you can go look at, or sign up to follow your own state requirements so you know when the states start enacting the rule. Next. I think that's it. So I'm happy to answer any questions about that, about the presentation or any other hazardous waste requirements.
Michael, there's a question about approved containers. UN 1A1, UN 1A2, etc., drums, for example.
I assume we're talking about for generation of hazardous waste. EPA, at the federal level, EPA does not state what an acceptable container is. It can be a 5-gallon bucket, or you can have a 1A1 drum. Certainly that's not, you can use that. Where the requirement comes into play is when it's prepared for shipment. So for satellite drums, there are no specifications in the rules for what those containers can be. They just have to be closed, labeled, and so forth. For the central accumulation drums, you have to meet the Department of Transportation requirements. So there are no EPA requirements per se, but you have to meet the Department of Transportation requirements. So I would recommend a 1A1 steel drum. That is probably the most common one that are used at facilities. And it's driven by the hazard class, class 9. So I can help you look those up if you have more questions, but I hope that answered the question. If not, raise your hand.
I have another question. Did Hawaii adopt new rule?
Let's go back to that slide, Belinda. I think so. Go back one slide. Oh, what color is Hawaii? Blue? Yeah, so I think it's blue. It's down there by Alaska.
It's blue.
Yeah, so they have adopted the rule. So it is in effect in Hawaii. More questions? All right, well, I thank you, and I look forward to our next in-person meeting.
Thank you, Michael. We're now going to take a 15-minute break. So let's return at 5:45 Eastern or 2:45 Pacific time. Thank you. Well, everyone, it looks like it's time to get started with the final part of the Lonza Plant Operator Seminar. Our next speaker, Rebecca, are you around?
Yes, sir.
Okay. Rebecca Curry is a PhD and is currently a senior toxicologist in the Regulatory Affairs Group of Lonza. She was formerly a toxicologist in the Product Stewardship and Regulatory Affairs Group at Eastman Chemical Company, and she was an assistant professor in the biology department at Roanoke College and a research associate at Virginia Tech. Rebecca earned her PhD from Virginia Tech, investigating ecosystems stressors from active and abandoned coal mine sites and industrial effluents. Rebecca is also certified as a senior ecologist by the Ecological Society of America. Rebecca will be speaking to us about hazards of working with pesticides. Welcome, Rebecca.
Thank you, Grady. Welcome, everybody. We're almost to the end of your long workshop day. Hopefully you have enjoyed the workshop so far and the presentations. We're going to kind of continue, obviously, talking about pesticides. I'm going to be specifically talking about some of the hazards of working with pesticides, kind of building on some of the things that Terry talked about previously. Oops. I got a little ahead of myself there. As I just mentioned, Terry kind of gave a really good overview about labels and some project registration, and I'm going to kind of build on that a little bit in the next 35 to 40 minutes with the intent of being able to take some of the information that you've already learned today and kind of tying that back together. So again, Terry covered labels, and as you can see, I've got the little cartoon there. It's really important to make sure that when you're working with pesticides that you're completely reading the label and you're understanding the information that's there available for you. And of course, it's a cartoon, but you know, it does list caution, first aid, active ingredients. All this is really important information. And you've already seen the read the label, little pictogram again. It's an EPA program, which is emphasizing how important it is for you to make sure that you're understanding the hazards that go along with the materials or the substances that you're working with. And in conjunction with that, you also need to make sure that you're understanding the information that's available to you on your safety data sheets. And so I've included one of the 9 pictograms. We really want you to be able to work safely and go home to your families at the end of the day. So having an understanding of what some of these pictograms mean can be very important if you have some type of a chemical exposure. For example, if you can quickly look at this one, it's the exploding chest. It's important to understand that that signifies that this material can be a carcinogen, a respiratory sensitizer. It can be it's classified as a reproductive toxicant or target organ toxicant. So there are some safety concerns if there is potential exposure. Again, there's 9 of them. One of them is the dead fish, dead tree. You may have seen that one. That's the environmental one, the one that kind of falls within my bailiwick. That one is not mandatory, oddly enough. So one of the 9 does not have to be on the label. It's the registrant is responsible for the manufacturer is responsible for providing that one. So as an agenda, I'll give a brief overview. Again, some of this you've already heard from Terry, but we'll just talk a little bit about pesticides and some of the different types of pesticides, and then we'll go into talking about some of the hazards from a toxicity and exposure point of view. We'll talk a little bit about risk. The goal will be to provide an overview or an understanding of what types of information that the EPA requires, because there really is it's a very large burden on the registrant to provide the necessary information with the goal of EPA making a definitive determination of risk. And that risk ultimately leads into risk mitigation measures, and these measures make sure that these pesticides are being used safely. They result in the PPE requirements that go on the labels. They provide the data that the manufacturers use to put on their SDSs. So hopefully, you know, having an understanding of some of this information will be useful to you. We'll talk about hazards, both for the environment and human health. I'll throw up the dose-response relationship so you can kind of understand how some of these endpoints are tied together. We'll talk a little bit about exposure for human health. We'll talk briefly about risk assessment, and then we'll end talking with some of the hazards and symptoms of pesticide exposure. I know you've probably seen the definition of a pesticide. You've probably heard it several times today, but we'll just go over a few of these things. So pesticide is defined as it's any substance, or it can be a mixture. It's intended to prevent, destroy, repel, or mitigate any pest. This definition also includes substances or mixtures that are intended to be used as a plant regulator, a defoliant, or a desiccant. Nitrogen stabilizers, which hinder nitrification or the ammonia volatilization process, are also included in this definition as pesticides. Plant regulators are also considered plant growth inhibitors, are very common nowadays. We see them used quite a bit. They started out being used mostly for horticulture and ornamental plants to keep plants short in kind of a stout structure, but now we're seeing them used a lot for grain crops to help keep them from being too tall and wispy, so they remain shorter and a little bit more stout, and they don't get damaged from storms quite as easily. So there's a lot of different types of chemicals that fit in this definition of a pesticide. So they're meant to control pests. That's fairly intuitive. We all understand that. And when you think of pesticides with the ICID ending, it's Latin. It means to kill. So you also see it used in words like homicide and suicide. So it's important to keep in mind that, you know, although even for home use, these things come in a spray can or a spray bottle or whatever, they really are intended to likely kill something. And again, Terry had shown a list of some of the common pesticides. So herbicides for weeds, and we have a variety of different types of insecticides. Molluscicides are used for mussels and clams, so shelled organisms. And then of course we've got, you know, pesticides that are used specifically for fish and birds, you know, rats and mice. Bacteria, insect and animal repellents are considered pesticides, and as are the antimicrobials, biocides, and fungicides. And pests, it's a very large definition. So they're any organism that is irritating or causes some type of harmful effect to humans, to our food source, or our living conditions. So everything from, you know, organisms, pests that eat crops, from locusts to even birds, to things that, you know, that bother you at home, mosquitoes, to, you know, if you have fleas and ticks on your pets. So pesticides are anything that realistically we find to be annoying or harmful. There's different types of pesticides, and we can get really far down into the weeds, for a lack of a better term here, but we'll keep this at a high level. But when we look at them, we've got broad spectrum pesticides. These kill a variety of organisms. As useful as they are to us, they can be problematic because they indiscriminately harm beneficial organisms. And examples are the organophosphates, the carbamates, pyrethroids, and obviously the neonicotinic insecticides that have been discussed previously. To give you an example, back in August of last year, back in August of 2020, up in North Dakota in Cass County, the Vector Control Department decided that they needed to do some mosquito control. They were worried about an outbreak of West Nile virus, so they had decided it was really important, and they wanted to get this done. And they decided to do a nighttime aerial spraying with a pyrethroid, very effective against mosquitoes. But it's a broad spectrum insecticide. It's got very specific uses on the label, and one of the things that they did not take into account is through that area of North Dakota, it's a very large monarch butterfly migratory route, and they just didn't take the time to realize at that time of the year in August that the monarchs were migrating through there, heading south to Mexico. So they sprayed overnight, and then of course when they got the next morning and everyone went out in their front yards, they realized that they had one of the largest monarch butterfly kill-offs that, you know, that we have seen in North America, and it really did cause a huge dent in the monarch butterfly population. So that's an example of a very effective broad spectrum pesticide. But in this case, it was not used quite properly. They should have made sure that they weren't going to have any issues with that. We also have narrow spectrum or selective pesticides, and these target specific organisms to a very specific mode of action. So we've got the rodenticides, miticides, and fungicides are a really good example of that because you can use fungicides on a lot of different types of vegetation and surfaces and things, and it's very organism specific. Pesticides can be organic. There's Bacillus as a bacterium that actually produces a toxic protein, and when it's ingested by nuisance insects, it kills them. It causes them to not be able to digest their food, and they ultimately starve to death. We can utilize this, and we do utilize this bacterium frequently, and use that toxic protein as an organic pesticide. We've also been able to identify the gene in that bacterium and insert it into the gene of a cotton plant, and it then produces that toxic protein, and it's very effective against some types of nuisance insects that would eat that plant. Kaolin Clay is approved by the EPA in 1998 as an organic pesticide, and neem oil, which you can get at nurseries and in local outdoor stores. It's the oil from the neem tree, and it's fairly effective. You spray it on tomatoes and cucumbers, and it prevents a variety of organisms from consuming them. But most pesticides are synthetic. A good example is glyphosate and DDT. So the mode of action is really kind of cool. So pesticides are designed to affect specific target sites within an organism. If they're broad spectrum, then it's a fairly common site that would affect everything from certain beetles to butterflies to a lot of different types of nuisance organisms. But we can also target this to a very specific site. This could be a protein or an enzyme that is inhibited or blocked. For example, or some organophosphates can bind to acetylcholinesterase, which is an enzyme that controls nerve signals, and we can interfere with those nerve signals and actually get those neurotransmitters to continue to fire. And the insects, if that's our target species, has no control over their movements, and ultimately they succumb to that. Glyphosate is also, it's an organophosphate. It interferes with a specific enzyme as well that plants need in order to make a protein to grow. And so it interferes with plant growth by not allowing that protein to be activated. And again, larvicides affect insects. They act as an insect growth regulator. They actually mimic juvenile growth hormones, and they keep that insect in an immature stage, which keeps it from maturing and being able to reproduce. So you don't just kill those organisms, but you prevent them from being able to reproduce. The population can't continue. So there's all kinds of really interesting things that we can do with these targeted pesticides. Terry mentioned this, so I'll just kind of go over this quickly, but when we talk about pesticides, we're really interested or really focused on the active ingredient. It's what's doing the work of the pesticide. It's going to be listed on the label, in the formulation. It has to be identified by name on the product label, and you include its percentage by weight. So it's what's doing the work. Along with active ingredients, one of the things that, from a hazard perspective, that we're interested in are the metabolites or the breakdown products that can form when a pesticide is released into the environment. So if it comes in contact with air, a lot of times it's when it enters a waterway or it gets into the soil, but it comes in contact with living organisms like microorganisms. You get these byproducts, and they can be more hazardous than the parent substance. For example, the biocide DBNPA is a fantastic biocide. They use it frequently in production facilities that have cooling towers. So it goes into cooling tower applications, and it works against of algae. So it keeps these systems somewhat biofilm free. But the degradants are more toxic than the parent material. So it can be problematic if you don't have the proper way to treat that wastewater from your cooling tower before it's released into the environment. So it can be a challenge for some customers to be able to use it because of that. We've already talked a little bit about indirect ingredients. These are other ingredients that are added to pesticides, but they usually impart some type of chemical properties, so they can be emulsifiers, solvent, carriers, propellants, and dyes and fragrances. So there's a big list of inert ingredients. The problem with them is they're often proprietary and they're not always listed on the label. And then we have the end use product, which is the final formulated product. And you don't go any farther than this. So it does not state on the product that you can continue to manufacture that or to formulate it into another pesticide product. So it is the final end use product. So all pesticides distributed or sold in the U.S. have got to be registered by the EPA under FIFRA, the Federal Insecticide, Fungicide, Rodenticide Act. It was most recently signed when they make changes and signed it was back in 1996. So it really hasn't changed much. But the registrant must show that using the pesticide according to what's on the label is not going to cause an unreasonable adverse effect on the environment. This is verbatim what comes out of the guidance or the act. And it's defined, FIFRA defines unreasonable adverse effect on the environment to mean any unreasonable risk to man or the environment. So that's where you get humans in there. So any unreasonable risk to man or the environment, considering the economic, social, and environmental costs and benefits, or a human dietary risk from residues that result from a use of a pesticide in or on any food inconsistent with standard, it's under Section 408 of the Federal Food, Drug, and Cosmetic Act. So we're not going to go into detail there, but ultimately EPA is responsible for determining if there is an unreasonable adverse effect, if there's the potential that we're going to have this effect. And what we're talking about here is risk. So risk is the probability of harm or an adverse effect if exposed to a hazard. In this case, we're talking about pesticides. So ultimately, EPA has to determine what's the risk, okay? And they're going to use the hazard information, which is the toxicity data and other data that is provided, and the potential for exposure. So those are the things that are driving our determination, or EPA's determination of risk. So EPA's got this nice risk paradigm. On the left, in the left circle, that's our risk assessment. So we start out with a hazard identification, which is looking at toxicity data and other data available. And along with that, they'll take those data and they'll do a dose response assessment. So they're going to have to take data that's developed from fish, and if we're looking at endocrine, it would be maybe frogs and birds and bees, and a variety of invertebrates and fate data and some other things. And they're going to have to try to take all that information and they're going to have to make it applicable to humans, right? So they're going to have to try to make it so it's relatable, so they can take the risk from all these toxicity data and they can then determine, is that going to be a risk to human health or the environment as well. And we're also going to look at exposure. So there's an exposure assessment component to this as well. And all this is used ultimately to do what they call a risk characterization. And once they have that risk characterization, then the next step is to make risk management decisions. And these risk management decisions are going to take into account what type of control options, are there legal considerations for this, are there socioeconomic benefits or factors that play into this, meaning we have a pesticide that's very specific for a certain type of nuisance pest, and there's really no other substitute for it, but it may be a little bit higher risk than they're comfortable with, but we really need it to protect these crops. And so they're going to consider all that and ultimately develop these risk management decisions. So you're going from collecting all the information that you can about this pesticide, doing a lot of different types of toxicity tests if necessary to complement what you already have, ultimately characterizing the risk and then making decisions on how to manage that risk and either include restrictions or PPE or control measures and things like that. So the EPA risk assessment, it falls into two categories. There's one for human health and one from the environment. They're done separately. The basic information is that the EPA is going to need is how much of the chemical is going to be present in the environment, how much contact is going to occur between people or wildlife or non-target species and the pesticide, and what is the inherent toxicity of the active ingredient. Okay, all this information is supplied by the registrant, either during a new product registration or a re-registration of an existing product, or potentially a new use to be added. So in the blue arrows, realistically, when a registrant wants to start this process of the registration for a particular pesticide, the EPA is going to open a public docket. It's going to be open for public comments. They're going to put together all the information that they have about the test substance or the pesticide. They're going to make that publicly available so people can write in comments. After that, they'll come up with a final work plan, which will comprise all of the information that they have in the potential areas where they don't have enough information, and they're going to issue a data call-in to the registrant. And that will, at that step, the registrant is going to go and do whatever toxicity testing or provide whatever additional data that the EPA requires. And then ultimately EPA moves into their draft risk assessment, which ultimately ends up in a proposed interim decision of their risk management decision, which goes out for public comment. And then ultimately they release a final interim decision. So when the EPA is looking at all this and they determine that there's any data gaps or that they need information, they're going to base this request for additional data on, again, what information the registrant has provided. This would include existing toxicity data, fate data. Fate refers to the fate in the environment, and any physiochemical data that's available. And Terry talked a little bit about this. So this would be pH, hydrolysis, anything that predicts how the chemical behaves, and then very detailed information on manufacturing process. So where's it going to be manufactured? What are the volumes? How long is the campaign every year? Where's the wastewater going? How are vessels going to be cleaned? What are you going to do with that wastewater? So all this has to go to the EPA. They're going to need to know the application rate, frequency, timing, method of application, specific crop or crops, pests that you intend to control, efficacy, all of that, and then storage and disposals. All this information goes into this registration package. If there's additional testing or information that the EPA requires in the data call-in, all of this testing has to be conducted following appropriate guidelines. So the EPA has just dozens of different types of approved guidelines for testing, from residues to birds to bees to you name it, and they got it. And so does Europe under OECD. So there's plenty of guidelines available, and they all spell out exactly what testing they wanted with, which species, warm water species, a marine species, and what guidelines. So all that is provided in the data call-in. Ultimately, this results in a final report that gets submitted to the agency. Is in the package. So from innovation of a new molecule to market, it can take up to 10 years and cost millions of dollars. So if you're doing the benchtop work with a new active ingredient, you've dealt with this new molecule and you want to take it to market, well, it's going to take a while, because you're going to start with efficacy, and once you realize that this may work against a certain pest and a certain crop, but then you have to start looking at toxicity testing, and these studies can range from $15,000 for a short-term acute study to millions of dollars for cancer studies. So it really can be quite expensive. So the majority of pesticides now are really just reworked existing molecules. So we really don't see a lot of new molecules coming to market anymore, because it's just so tedious and expensive. So the toxicity data required for the DCI, or the data call-in for human health and the environment, it's going to be determined by the characteristics and the potential exposure. So if you're going to be using this in the middle of Iowa, then EPA is not likely to ask for a lot of marine species when they look at the testing data that's available. So it can be a little specific based upon certain characteristics and potential for exposure. And they'll ask, you always have to do testing on the active ingredient. In some cases, they'll ask for testing on the formulated product as well. So when we talk about testing, the data that's going to drive the risk assessment also contributes to the safety data sheet. So it's going to go a lot of different places. So we talk about acute testing, and this would be for human health and the environment. We're talking about short-term exposure. So the endpoints are going to be reported generally as lethality, immobility, or impairment. The duration of the exposure is, again, it's short, anywhere from 24 to 96 hours, depending upon the guideline. Inhalation studies can be even shorter than that. They're about 4 hours in exposure. We often will test in just one single dose. So you'll either put it in food that goes to an animal, or we put it in, obviously, in water for aquatic organisms. And sometimes you make up concentrations and we put our organisms in there. But sometimes if we think that there may be toxicity or there's going to be potential exposure, especially if it's repeated exposure, then we may do multiple doses. So this would be a repeat dose study. If it's an aquatic test, we can't just keep adding more of the material, of the active ingredient, into our test concentrations, into our vessels. We'll run these in a flow-through system, or we'll renew them by actually making up new concentrations and just moving the organisms over. The endpoints are time-based effect concentrations that show an adverse effect to 50% of the test organisms. So if we're looking at lethality, we would call that LC50. If we're looking at an effect like immobility or impairment, that would be an EC50. And if we're looking at a dose, say for human health, and we're looking at testing in mammals, it would be an LD50. In the old days, you would generate these values by just, you could draw yourself a graph and do the interpolation by hand, but now we have software that generates these data for us. So chronic testing is longer term. It's looking at sublethal effects. So we're not looking at mortality in chronic testing. We're not worried about lethality here. You've already likely done a lot of acute testing. You know where your acute toxicity value is, and you want to test below that for your chronic study. And you're going to look at things such as inhibition of reproduction, which is fecundity, or the inhibition of growth. So we'd be looking at whether or not fish weights change over time. So the endpoints are going to be determined statistically by comparing them back to the control organism. So if you're doing a fish study, or again, we're looking at weights, we may look at dry weights. We're going to look at how well our control organisms perform, and then we're going to compare all of our organisms out of our different test concentrations back to those control organisms, and we're looking to see if there's a difference. In chronic studies, we report what's called a no observed adverse effect level or concentration. This would be the first concentration above our control where we see no statistical effect, and then the first concentration where we do see an effect is termed our lowest observed effect concentration or level. So when we're talking about the environment, we're talking about ecotoxicity testing and environmental fate. If we're looking at aquatic systems, because again, the characteristics and the exposure potential for the pesticide dictates the type of testing that you have to do. So obviously, in most cases, when you're using pesticides, they have the potential to enter aquatic systems. So you almost always see aquatic testing requirements. So this would include fish, invertebrates, and algae in both freshwater and marine species if necessary, and a variety of aquatic plants, like duckweed. Terrestrial toxicity, you would look at plants. There's a huge number of crop plants that get tested, even though they may not be the crop that you're going to be using this if it's a herbicide. If you're going to be using it on as your target crop or the crop that you're trying to protect. But we've had a very large list of different types of plants. Bees and birds obviously are very important. And we use things, earthworms, a variety of arthropods. There's just it's a really large number of different types of species that we can get data from. So these environmental data are used in the environmental risk assessment, and they are used to determine what's called an environmental effect concentration, or the EEC. And this realistically is a concentration in the environment above which you don't want to exceed. So this is kind of the cutoff. We don't, based upon looking at all of these different test data and these different species, this is determined, the EEC is determined to be above which concentration you don't want to exceed, because you may see some effects in some of your sensitive species. If we're looking or talking about environmental fate, we're looking at what happens to the active ingredient or the pesticide in the environment. Where does it go? What happens to it? Does it biodegrade? Biodegradation would occur when microorganisms convert your active ingredient, your pesticide into carbon dioxide. We could have hydrolysis. We could see soil and sediment metabolism occurring. We could see absorption. It may compartmentalize and stay within sediments or soils. We'll do a variety of activated sludge studies to see if the microbes in sludge help to break this material down. We want to know, is it going to bioconcentrate up the food chain? Does it have the potential to be an endocrine disruptor? So the EPA will evaluate the potential for the active ingredient to be biologically degraded, to persist in a variety of different compartments, to bioaccumulate in the food web and bioconcentrate in organisms up the food web, the food chain, and if there's the potential for any endocrine disruption. So for human health, we look at acute toxicity. We're interested in irritation and sensitization, and these are all initially evaluated in a series of 6 toxicity tests termed a 6-pack. For the environment, if we do an algal, a Daphnia magna, which is a freshwater invertebrate, and a fish study, that's termed a 3-pack, and that's fairly standard for environmental testing, for aquatic environmental testing. But for human health, we do the 6-pack. So we have the oral and dermal toxicity along with inhalation. We've got eye and skin irritation, and then skin sensitization. This is really kind of the minimum data set that EPA is going to require to try to make a determination about risk. And these studies provide initial data that's used for classification and some of the precautionary labeling that goes on the SDS and the label. When we talk about human health, we've just previously talked about chronic testing, but some of the human health studies are considered subchronic. They're not as long-term as, say, a cancer study or a multi-generational study, but they're also not considered acute. So those are termed subchronic. They're conducted as a repeated exposure, repeat dose over a limited time. In this case, 28-day or 98-day repeated dose. It's frequently done, and this can be in mice, rats, and rabbits. We can look at multiple routes of exposure, oral, dermal, or inhalation. And this evaluation is going to be different from the acute testing because it's going to be a little bit longer, and there's going to be a necropsy. It's kind of like an autopsy. It's going to evaluate organ and tissue health. So we're going to look at the various organs and body weights, and do they appear to be, when you're looking at the pathology, do they appear to be healthy? So it gives you a little bit more detail than your acute study. So every time you go from an acute study to a subchronic or a chronic study, you're getting more and more information in order to be able to make that determination of risk. There are genotoxicity studies. This is called genotox battery, which would include an Ames test. The Ames test uses bacteria to test if the chemical causes any type of change in the bacteria's DNA. There's an in vitro mammalian mutagenicity test. It uses a somatic mammalian cell lines. So again, look to see if there's any type of changes to the genetic material. And then a chromosome aberration study looks at, again, it's a bacterial study, looks at any changes in chromosomes, like they become shortened or cut or damaged in any way. So these 3 studies are all in vitro. They'd all be benchtop. They don't use, other than bacteria, they don't use live organisms or whole organisms. So chronic testing, we're talking about human health here, it's conducted to evaluate long-term effects, very similarly when we were talking about the environment. But it's going to look beyond just at organ weights and organ pathology. It's going to look at developmental impairment and damages or changes to reproductive organs or to fecundity, to the number of offspring that are produced. We have multi-generation development and reproductive testing that's going to look at the effects that occur in fetuses. So you expose pregnant mice, rats, rabbits, and evaluate how the pesticide is affecting reproduction. And you can look at both gestational females and in some cases males will be included, and you may have exposure prior to mating these organisms as well. So there's neurotoxicity testing. Example of a neurotoxin would be mercury and lead. Again, these are done generally with rats, and you look at the fetal development. There's mutagenicity testing to assess the potential effects on the cell's genetic material. Endocrine assays, there's a battery of 11 different types of endocrine assays that Most of them look at the effects in humans, and some of them look at the effects in aquatic animals. It would specifically be fish and frogs. And then cancer studies are at the top. They're the tier 1 studies because they take the longest and they're the most expensive and most difficult and challenging to conduct. This is an example of dose-response relationship. It just gives you an idea of when we talk about some of these endpoints from toxicity testing, kind of where they fall out. Again, most of this is software generated now when we run these toxicity studies, but you know that it's a simple interpretation here is to look at the graph, and you can see the LD50 value is, you know, where you're losing 50% of your test organisms here about in the middle of the graph. So at this dose level, so between 20 and 25 milligrams per kilogram, you would expect that you would lose half of all your test organisms. But your NOAEL and your LOAEL values are lower. They're more conservative because you're looking at sublethal and not lethal endpoints. And then we have way down here the DNL. So the DNL is the derived no effect level above which humans should not be exposed. And it realistically, it's like the EEC, the environmental effect concentration for humans. We do not want to see concentrations above the DNL in the environment or where people are becoming exposed to, because it's a very conservative. That's why it's, you know, if you've got an LC50 value over here at 22.5, you know, you've got a DNL that's likely at 3. I mean, it's a very conservative and it's very protective of human health. All right, so we'll skip on into risk. Again, remember hazard, which is the toxicity data, combined with the potential for exposure gives us our risk, our idea of risk. So risk from exposure is affected by the individual overall health. So how healthy you are is going to affect how well you deal with risk to some of these toxins or pesticides in the environment. And age, gender, allergies, and underlying health conditions and pregnancy all contribute to this potential risk from exposure. And emphasis is always given in risk assessments to protect susceptible populations, children and pregnant women. It's one of the reasons why the DNL is so conservative and so low, because it's EPA's goal is to always be protective of susceptible populations. So the potential for risk is affected by the duration. How long is the exposure? Is it single or repeated exposure? What is the concentration in the environment, generally reported as parts per million, parts per billion, and the dose. So the dose is the amount of a substance that enters the body and is usually adjusted for body weight. So milligrams per kilogram body weight per day. Not all doses of a toxin or other substance are harmful, and that's important to keep in mind. So aspirin, sodium chloride, table salt, so oxygen, and even apple seeds can all be toxic. Apple seeds are kind of interesting because they contain cyanide. So when you chew apple seeds, you're releasing small amounts of cyanide. Obviously, you never hear about anybody that dies from eating apples. So it really is this idea that the dose makes the poison. Okay, and another example is BPA. It poses no health risk to consumers because it's at such low concentrations, so your exposure potential is so incredibly low. And then on the right, you see this frequently. It just kind of gives you an idea of some lethal doses. So 6 liters of water can be toxic to, you know, individuals will vary, and not everybody's exactly the same. 118 cups of coffee, 13 shots of alcohol. Again, you know, some people could take less, some can take more, but these are things that we consume all the time, and there's no toxicity because the dose is generally too low to be harmful. So for routes of exposure, so for inhalation, we're talking about, you know, breathing in through your lungs. Dermal exposure, it can be contact or absorption through the skin. Ingestion obviously is fairly straightforward. You consume it, either swallowing a liquid or somehow another route, other way it gets into you ingest it through your mouth, into your mouth. Eyes, you can have absorption into the body through your eyes, or you can have direct damage to the eyes. So the route of exposure is going to be dictated by the type and the use of the pesticide. Dermal exposure is the most common for applicators. So generally it's just a contact dermal exposure. but inhalation exposure, although it's less common, it poses the most serious risk. Obviously, you can, if you needed to, run to the sink or the safety shower because you've got some type of contact dermal exposure, you rinse that off, is a lot easier than dealing with an inhalation exposure. So for human health risk, there's 4 steps. So there's a hazard identification, which is the toxicity, which we've already talked about, of the active ingredient or the formulated product. There's going to be the dose response assessment, which if you remember the circle on the left from the EPA risk paradigm. So this is going to determine the numerical relationship between exposure and effects, and it's going to be used to estimate equal doses in humans. So it's important to be able to make that conversion. The exposure assessment is going to look at frequency, timing, level of contact with the pesticide. Ultimately, we get the risk characterization, which gives us an idea of the overall risk. And at this point, if EPA is being conservative or they don't feel like they have enough data to make a definitive determination, or that, again, they want to protect susceptible populations, at this point, they sometimes will insert a safety factor. So they'll make the risk characterization even more conservative. But the goal is risk management. And this is going to include the hazard warnings on the label, the PPE requirements, and restrictions on volumes, uses, and applications. So this is kind of where EPA says, yeah, this is not that safe if you use it this way. This is what we're going to require. You're limited your volume. You're going to be limited to only these applications, or we're going to have very stringent PPE requirements. For example, a human health risk assessment may determine that there's a high risk for inhalation toxicity during commercial use of handheld spray equipment. So they may restrict this end use, saying you cannot have any type of commercial use of handheld sprayers, no using the Wagner power sprayers. You can only use brush-on applications, or they may require that a full face respirator is worn. So they can make adjustments based upon the risk characterization. So now we're getting down to the hazards. We'll just go over these fairly quickly as we're almost done. So when we talk about hazards, some of the things to consider is you can always have the potential for the contact adverse effects, and this could be from a dermal exposure, which ultimately can result in a rash or a burn to the skin, or it may result in a dermal absorption into deeper tissues. So it's very important to assess that if there's an exposure, to make sure that it's treated quickly, because not only can you end up just, the poison ivy gives you a rash, you don't get any type of dermal absorption from that, but other types of chemicals can be absorbed through the skin. You can have systemic adverse effects where you get localized exposure that spreads to other parts of your body or your organs. There can be allergic adverse effects. This can be contact or systemic. So rash, hives, you can go into anaphylaxis. The sensitization is a problem because it can happen only after one exposure, and it's not dose dependent. So it's always very important to be aware of any type of potential exposure, because it only could take one time for you to become sensitized. And the pictogram on the right with the exclamation point is the one for skin sensitization or irritation. So if you see that one, it potentially is a skin sensitizer, or it's going to be an irritant. There are a variety of different types of symptoms from pesticide exposure, going from mild to moderate to severe. Again, if you ever have any type of exposure, you need to make sure that you're following up on that to make sure that you don't experience any of these things, but you keep track of how you feel. A lot of times you have a headache for a lot of different reasons, for stress or whatever. But it becomes more severe than that, and you experiencing vomiting, coughing. If you see these symptoms start to progress, you really need to make sure that you're taking proper precautions and following up with medical professionals to make sure, and that it's been reported properly that there may have been exposure. And this is where knowing the labels and the SDS and the potential hazards for the material that you're working with becomes very important, because, like I think Terry mentioned, you don't want to go running in there with a bottle, but it would be helpful to have the label and the SDS. So when we're talking about wood preservatives, they're pesticides, and you've covered this all day. The toxicity for these pesticides will be determined by the specific active ingredient, so it's important to make sure that you're reading the label and the SDS. The routes of exposure will depend on contact with a formulated product or article. So it depends on, how you're handling it, how you may be exposed. The labels and safety data sheet, you need to read these to be safe. Again, Alonzo wants you to go home every day after work. Make sure you're using the recommended PPE. That good housekeeping is very important. It's above just reading the label and the SDS and having the proper PPE. Good housekeeping in your facility is very important to make sure that you're not having any potential exposure. And I'll wrap up with an example with CCA, because it's obviously, and it's very important to all of us today. So when we're talking about CCA, we're talking about potential exposure to chromic acid, arsenic acid, and copper oxide. And although you may think, well, I work with this all day, every day, it's not really a problem. Copper is, not an issue, and copper really isn't. Copper has low toxicity to humans, but it is toxic to aquatic organisms. So when you're working with copper, it may not be so much that you may have any potential exposure or problems, adverse effects, but we don't want it getting to the environment. So a lot of times copper-based products, you're going to see dead fish, dead tree, because we don't want it, again, being released. But the primary concern for CCA is the arsenic. So the arsenic component has some toxicity to aquatic organisms or to terrestrial organisms, but it is very toxic to humans. The DNL for arsenic is 12 micrograms of arsenic per meter cubed for inhalation. So it's an inhalation toxicant. And 600 micrograms per kilogram per day, it can produce mortality. So it's not just the CCA, it's actually the individual components. And it's important to read the label and the SDS and understand that. So if we look at, whoops, once my mouse gets out of hand here, and this is the last slide. If we look at the information on just arsenic and you were to look at the SDS, again, it's an acute aquatic toxicity category 1, which is the most severe, and chronic 1 as well. So you get dead fish, dead tree. And then for humans, it's a category 3 inhalation toxicant, and it has acute toxicity. So you get skull and crossbones. So you would know that there is the potential for adverse effects if there's any type of exposure. So again, read the labels, look for the proper PPE. It's in section 8 of the SDS, and then follow any type of requirements that there may be at your manufacturing facilities. And again, if you have any questions about any of these products or you need information, there's many sources available for you. We're all very happy to answer any questions you might have.
No questions here, Rebecca. Thank you.
Thank you.
Thank you, Rebecca. Our next speaker is Kim Merritt. Kim is the Director of the Treated Wood Division of the Southern Pine Inspection Bureau. SPIB is the rules writing agency for Southern Pine Lumber and is accredited by the American Lumber Standard Committee and the International Accreditation Service as both an ISO IEC 17020 inspection body and an ISO IEC testing laboratory. Kim has 31 years of experience and is a member of AWPA, where she has served as the P5 Analytical Methods Committee Chair, the P1 Preservatives General Committee Chair, and is 2018-2019 AWPA President. Kim is a member of the Forest Products Society and several industry and association task forces, and serves in an advisory capacity for various industry associations committees. Please welcome Kim Merritt.
Let me get myself unmuted. Thank you, Grady. I appreciate that. It sounds so important when you read all that off. Belinda, do I have control? Let me see. See if that's working. Yes, okay. So I know everyone's had a super long day and we're ready to wrap things up, and I'm happy to be here and be the last presentation on your agenda today. First off, I want to thank Lonza for asking me to be here. It's always exciting to get the opportunity to visit with everybody, even if it is virtually. But it feels like we haven't had a chance to visit in person in a very long time. So what I did with this presentation is I tried to incorporate a lot of our team pictures, our lab team pictures, and some videos, and just try to give you some good information about in-plant quality control and make it fun at the same time. So thanks, Lanza, for asking me to be here with you guys today. So first thing, just to talk about who we are and what we do a little bit. And if you don't know, I work for the Western Wood Services. I'm the director of the Treated Wood Division, and Western Wood Services is a division of SPIB, the Southern Pine Inspection Bureau. SPIB has actually been around for over 100 years as an organization. But in 1940, we were separated as the Southern Pine Inspection Bureau. We're a not-for-profit company, and we are responsible for writing grading rules for Southern Pine, but also just ensuring product quality for all species and treated wood and grading. And in doing that, we like to also participate. It's very important to us to participate in education like we're doing today, and just promoting industry sustainability as a whole. So picture here's our lab crew, and we're having a good time with this. So like I said, Western Wood Services, that is the division of SPIB that is dedicated to the products and producers in the Western US. So that is for both grading and treated wood inspection. And we have a logo specific to our Western division. And that is pictured here. And then just a little bit more about our laboratory. We are accredited for a full range of analytical methods. This includes chromatography, spectrophotometry, wet analysis, and X-ray spectroscopy. This gives us the ability to analyze basically all the wood preservatives that are on the market today. We also participate in research along with task groups in AWPA to bring new preservatives to the market. So our lab is participating in all of those facets of the industry, as well as taking care of your everyday in-plant analyses and inspection samples as well. As we all know, this picture kind of makes me laugh, and I thought you might too, because it's been an extraordinary year and a lot of trying times, and I know that you have all struggled along with us, and we've tried to keep our spirits up and have a good time. We've analyzed a whole lot of samples in 2020, expecting to this year as well, and just appreciate everybody working together and making this crazy world work right now. So this is our lab team having a great time in the process. So just to quickly tell you a little bit about our accreditation as both an inspection agency and a laboratory. You know, you think of third-party inspection as we're in there and we're inspecting things and making sure that you're doing things right. Well, someone inspects us as well to make sure that we're doing all the responsibilities that we have as an agency and as a laboratory. And so if I just kind of go through those really quickly, we're accredited by the American Lumber Standard Committee, and I'll tell you a little bit more about them in just a minute. Also the International Accreditation Service, and that was those numbers that Grady was reading off in the beginning of the introduction. The 17020 is a standard that lists the requirements for inspection agencies. So IAS comes in and makes sure that we're meeting all of those requirements. The 17025 is the standard for testing laboratories, and they do the same thing for us. Then they come in and they audit us once a year to make sure that we're doing all the things that we should be as a laboratory, and we're meeting the standard requirements. And then we're also accredited by the Department of Housing and Urban Development. So if you see the Western Wood Services or SPIB mark on a piece of lumber, it is approved for any projects that are funded by the by HUD, by the Department of Housing. That is something that not everyone knows, and it's kind of funny because they show up at our door whenever. Might be every year, it might be every 10 years. But this is a list of people that oversee what we do and make sure that we're doing what we need to be doing. Next, just to talk about ALSC. So ALSC is a nonprofit organization. It's a committee, and it's made up of manufacturers, distributors, users, and consumers of lumber. They serve as the standing committee for the American Softwood Lumber Standard, the Voluntary Product Standard 20, and that's called PS 20. And basically what that does, it ensures that lumber producers are marking and grading material in a organized way. Well, let me see, I have notes just so I can make sure I'm reading that right. Let's see, yes, so they're doing they're grading in a uniform and industry-wide manner. So that's what Product Standard 20 is. It also administers accreditation programs for quality marking of treated lumber, and that is done under the standards maintained by the American Wood Protection Association. And we'll talk more about those standards here in just a minute. There's some other programs that ALSC oversees, and that includes the IPPC, the packaging program, to make sure that materials are sterile before they're exported to other countries. So let's talk a little bit about the International Accreditation Service that looks at us as an inspection agency and as a laboratory. So they accredit us to standard 17020. And just like I said before, really quickly, they look at our inspection activities and they make sure that we perform inspections according to this standard. And they do the same thing with us in the laboratory. So if we are performing analyses according to an AWPA standard, they come in and observe us and make sure that we're doing all the things that the standard requires. So just to get into the meat of this presentation, let's talk about, I'm going to get really nerdy with you here for a few minutes. So we're gonna wrap it up in a fun way. We're going to talk about the elements of effective in-plant quality control. So let's get right into it. Element 1, know your standards. So as I mentioned before, we are inspecting your product, analyzing your product, sampling your product according to the standards of the American Wood Protection Association. We also inspect product according to ICC evaluation service reports, and some of you are familiar with that, ESR numbers. But those evaluation service reports, they reference AWPA standards. So when you get down to the requirements of what we do every day, it's AWPA. So we're going to talk about AWPA a little bit more in depth as we go through this process. So AWPA is also a nonprofit organization, and their whole goal to be in existence is to write wood preservation standards. They are accredited by ANSI, and it is a consensus-based process. So individuals are on committees in AWPA, and these individuals are producers of preservatives and preservative components. They're producers of treated wood. You have untreated wood product manufacturers being represented there. End users of treated wood, and there's engineers and architects and building code officials, scientists from universities, and also general interest groups like inspection agencies. So those are all part of the process. And when we say consensus-based, it means that we all get together in committee and we look at data, and sometimes we fight it out, and majority wins, and we write those standards in that process. It's not always easy, but it's a good process because all of the industry is represented as we write these standards together. Let's see, just to say that AWPA is also standard for wood preservatives in the US, and it's also nationally internationally recognized. Okay, so we need to look into this book a little bit more. I personally feel like my superpower is the ability to read and interpret the AWPA Book of Standards. As treating plants and treating plant operators, you should have a copy at your plant location. And if you've ever opened it, you've probably been surprised by how hard it is to follow. So we're going to take a little tour of that book and figure out how and why we do what we do. So let's do that. The use category system is the main part of the book. The biggest part of that book is that use category system, and everything else kind of follows along behind that system. So the use category system is broken down into two different groups. You have U1, which is user specifications, and you have T1, which is processing and treatment standards. And under each one of those two groups are commodities, and they match. There's specific information for each commodity. There's sawn products, posts, ties, poles, piling, composites, marine applications, fire retardant, non-pressure applications, non-pressure composites, and barrier systems. So under these two groups, you have these specific details and specific requirements for each type of product that you're producing. So if we look closer at U1, what kind of information are we going to find there? We're going to find service conditions. You see these descriptions every day: above ground, ground contact, heavy duty, all of these things. So we're going to find out what those things actually mean. We're going to find that in U1. We're also going to find the list of preservatives and species that have been approved under AWPA. We're going to find the commodity specifications that I just listed, all of those different types of products. We're going to find requirements for those products. We're also going to find marking requirements. Everyone sees tags that have the WWPI check mark on them. Well, in U1, commodity specification A for sawn products, that mark is required to be on that material if it's represented as meeting an AWPA standard. You'll find that information there in U1. You're also going to find special requirements, for instance, like for permanent wood foundation or marine. For PWF material, foundation material, that is a higher level of inspection. All of those samples have to be sent into a third-party laboratory for confirmation before you ship that out. All of that information is listed in U1 under the special requirements section. So if we wanted to look for something, we needed a use category 4A for a sawn product, and we had Douglas fir that we were treating, and we wanted to treat it with CAC, we would find that for UC4A, that material would need to be treated to a 0.15 pound per cubic foot retention. So that's where we find that information. That's in U1. Okay, so moving on, these use categories. There's basically 3 different groups. We have above ground, we have ground contact, and then we have marine applications. And U1 describes all of those. If we go through and we look at the above ground applications, we have interior construction, we have interior construction protected from liquid water. That would be like boron applications. Or you could have UC3B above ground that is exposed, but is for less severe environments. And those descriptions are listed in U1. And then we also have the ground contact. We have general use, that's for ground contact or fresh water. And then we have heavy duty, that is for critical components or if something is difficult to replace. And then we also have critical structural. So those descriptions are in U1 if you ever want to look them up or you need to communicate that to a customer, that's where you go to find this information. And then, of course, we have the marine environments that we were talking about earlier, and they describe, like if we look at UC5C, We're looking at salt or brackish water adjacent to the mud zone south of Georgia, Gulf Coast, Hawaii, and Puerto Rico. But if we want to find out what marine treatment we need, we would go to AWPA to get that information. So AWPA has done this. One of the committees in AWPA has put together this residential infographic. This is really helpful. You can find it at AWPA. You can download it and use it. But it just gives you examples of residential uses of preservative treated wood and what use category you should specify when you're using the treated wood products. So if we're looking at structural posts, of course, that's color coded. It needs to be ground contact. If we're looking at stairs, stair stringers need to be ground contact, but some of the components of stairs might be okay at an above ground application. If we're looking at deck boards, those are listed as above ground. So how do we know? What's the definition of above ground? Well, it's really nice because they've put together this definition of above ground for us. It needs to be at least 6 inches off the ground. It needs to be able to dry. If it's staying wet all the time, you might need to go up to a ground contact application. If it's in an application where it might accumulate like leaf debris or something like that, or it's any kind of more severe environment, even though it's technically off the ground, you might want to go up to the next retention level. And that is defined here in a graphical way. So it's easy for everyone to take all of that technical data out of the standards and put it into this form. And I'm pretty sure that Lonza probably has something like this for you as well. That just puts all of this information together that's easy to understand for you and your customers. One of the other things that this infographic does for us is it helps us to understand the end tag and what all of those pieces of information on the end tag actually mean. So if we take that and we blow it up, I just kind of wanted to go through it with you guys to talk about treated wood end tags. And of course, you have your inspection agency information there. You have the check mark if it's required by AWPA. And what that is just this quick symbol that consumers of treated wood can look for and know that that product was treated under an AWPA standard. And then also it gives you the preservative type and retention, the treater name and location, the AWPA standards and the use category, and of course the end use application, which is what we've just been going through here. Okay, so if we switch over to T1, T1 is for process standards. So that tells us different information. That's going to tell you as treaters the type of information that you're going to need when you're treating your product, when you're inspecting your product. So that information is treating requirements, whether a certain species needs to be incised or not, or what the process maximums might be for plywood. That kind of stuff is there. Also, the results of treatment. It also gives you preservative component minimums. So when we're treating to a certain preservative system, we not only have to meet the total preservative retention, but we also have to meet the retentions of the components that make up that preservative. And that information is in T1. QC and inspection requirements are there. Retreatment requirements are there. Drying after treatment. Special requirements by commodity. And also the penetration specifications, assay zones, and sampling requirements. So if we wanted to look at Doug fir or hem fir, and we wanted to know the penetration requirements, this is where we would look. We would look in T1 and we would see that we need 20 cores. 80% of those cores need to be conforming for the charge to be passing. And our penetration requirement is 0.4 of an inch and 90% of the sapwood. So that's where we find this information. So M25, that is an important standard for you because it gives you all of the information that you need for the inspection of treated wood products. So this is where you're going to be looking every day for how to inspect this material after it's been treated. It's going to give you the equipment that you need, what you need to do to calibrate that equipment, the suitability of products for treatment, product identification and traceability, Sampling requirements, sampling pattern. How do you take a sample out of incised material? The use of indicators, results of treatment testing, and then retreatment. All that information is going to be there in M25. So that's a very important standard for you to know, be familiar with. And then your records and reporting, what you have to do, what records you have to keep, how long you have to keep them. That's all in there as well. So the indicator standards, these are A standards. That stands for analysis standards. So when you are taking your samples and you're applying indicator, you're actually doing a laboratory analysis, and that's pretty cool. So all of you guys listening right now that are taking samples and applying indicators, you're lab techs and you're performing laboratory analyses every day. So A49, that is a standard that tells us how to indicate the presence of heartwood and pines and Douglas fir. And then A68 and A78 tell you about how to indicate for borate, the presence of borate. A69 is for the indication of copper, the presence of copper, and that works using a chemical called chrome azurol. And then we have another standard for indicating copper, and that's A72, and that is using rubianic acid. Now, the picture of this cool guy that I have right here, this is Robert Boyle, and he is the inventor. He's credited with the first visual indicator test, the litmus test. So when you're checking for a pH, he came up with that. So because he did what he did, we can do these things for wood preservatives now, which I think is pretty cool. So each of these standards, they're going to give us the instructions. You're going to have these indicators at the plant site, and these methods are the instructions for how to use them and how to interpret what colors, when they change colors, what does that mean? And the instructions are listed in these methods. And then if there's any known interferences, you need to know when these indicators will work and when they won't work. And that's important information if you want to get a good analysis, a result of how that wood is treated. And that's the most important thing we do every day, right? Is when we treat that wood, we want to know if we treated it properly. And we need to know these test methods in order to do that, okay? So A9, that is another analysis standard, and it's the one that you're doing every day when you're using the X-ray to analyze copper or CCA or ACZA on your X-ray analyzer. So I've got a little video here. This is our lab tech, Amanda, and she's just awesome. And she's grinding the sample. So if we're reading A9, this tells us everything we need to know about how to analyze samples by X-ray spectroscopy. It tells us our safety precautions, the apparatus that we need in order to perform the test properly. It tells us how to prepare our samples, also how to calibrate, so we can do that and know that we get a good answer. We can put some wood in there and get an answer out, but how do we know if it's a good answer? How do we know if it's a right answer or an answer that we can depend on? So this is the instructions on how to do that. So moving on, I think I've covered that. Element 2. Okay, let's move on to know your incoming material. So when you get a bunch of wood in, you're fixing to treat it, what do you know about it? You have to know your incoming material before you can treat it properly, right? So there is some information that you need to know. First off, when you get the material in, you need to make sure that it's stored properly, so it's equilibrated properly, so it's ready to be treated, right? That's very important. Also, we need to know the moisture content. Take moisture content checks of your material, know what you're treating before you treat it, and then stage your charges as consistently as possible. When we're trying to analyze wood products, the biggest adversary that we have is variability, the variability of the wood itself. And we're trying to overcome that every day. And to do that, we need to do as much as we can to lessen variability. So when we stage charges consistently, when we put like items in the cylinder together, we lessen that variability and we have more confidence in the results that we get at the end of the day. Okay, so if we look at a grade mark of incoming material that hasn't been treated, there's a lot of information that we can get there, and it's important information. We get to know what mill this material comes from. Different material from different mills, they treat differently. And so we can find out a lot from data, from results from each mill. And we can look at that data and we can set up our charges and our charge parameters to fit the material, the incoming material. We can also find out about the grade of material and how that treats differently. We can find out about the seasoning. I know my example's old and no one really uses this term anymore, but that seasoning information is there. So we know if the material has been dried, and that is very important to the results of our treatment. And then we also have the species, of course, and that determines how we analyze the material, how we treat the material. So pay attention to those things and try to lessen the variability in the cylinder as much as you can, because you're going to get better results and you're going to be able to control your process much better when you do that. Okay. So if we're moving on to element 3, good in-plant sampling techniques. So you've treated your material, but you want to find out how that worked. Was it successful once you did that treatment process? So if we look at that a little closely, and I'm talking to Western treaters, we're gonna make sure that we don't sample anything closer than 3 feet from the end of the piece. Okay, so this is coming straight from the AWPA standards. So we want to make sure that we are sampling the center. So if we have a piece of wood, we're going right in the middle and we're perpendicular. So we're not going at an angle, we're going straight in. And we're going to avoid obvious defects in that process. There's no point taking a sample right in the middle of a knot or something, or some defect there, because that core won't do us any good and won't be contributing to our analysis result. And I'm going to get to the blue part in a minute. I wanted to, I pulled this out. Incised material, you want to take the borings in the place that will have the least influence on your penetration results. So depending on the incising pattern, you're going to want to go between these incisions. And if you have boards that have incisions that are more dense on one side than the other, you want to take your sample on the less dense side, because you want to get the worst case scenario. You want to know how that piece treated on the side with the fewer incisions, so you can really get a good look on the success of that treatment. If you take your 20 cores and you get a penetration that is very close, or that is 4 cores, you can take additional sets of cores. The AWPA standard will allows you to do that. The more cores we take, the better picture of that charge we get. So that's always encouraged. But no, when you take the 20 cores, when you're putting all of those, all that core data together to assess penetration, you have to analyze those 20 sets for retention separately and then average those results. So keep that in mind. If you do that, that's the way AWPA requires that we handle those samples. Okay, so take a representative sample. What does that mean exactly? Well, M25 requires that we take samples in a pattern. When I say in a pattern, it means that we do it the same way. When we have a charge of material that comes out of the cylinder, we want to see how many packs are in that charge, and we want to make sure that each pack is represented, or as many packs as possible are represented in our sample, and that the sample represents that charge. And the pattern tells us that we should sample boards on a random basis. So some boards treat differently than others. So if we don't sample in a pattern and everyone's sampling the same way, we can unintentionally bias our samples. Or if we were of a mind to, we could intentionally bias our samples, and we don't want that. We don't want that to happen. So we always want to take our samples in a pattern. So you can see here the holes here. In this example, they skip the top board, they sample 2, they skip 1, they sample 2. And everyone at that plant does it the same way. The inspector does it the same way. And this keeps everything random and keeps us from skewing our results one way or the other, which is something we don't want to do. When you have a charge that has large variations of material in size or the way that the material treats, I would highly encourage you to take 2 separate samples. Sample those sizes independently and see how they treated. And that way you lessen the chance of a differing answer when your inspection agency comes along. If an inspection agency comes along and takes a sample and it was a completely different material than what you sampled, you're going to get a different result. So you want to know what the agency is going to find before they ever get there. And this is a good way to do that. Okay. So, and this is just a little bit more information about why sampling in a pattern. This establishes a method for taking samples that eliminates bias or removes as much bias as we can. And it's prescriptive to lessen the variability that we see. We see that, you know, the way that lumber is cut from the log determines the grain of the material, and those different grain patterns, if you have flat saw material, a quarter saw material, that material treats differently, and we want to make sure that we're randomly picking those pieces. Okay. Let's see, what's next? Core length. We have to make sure that our core length is the right length for the material that we're sampling. So if we're looking at sapwood species like southern pine, our cores need to be 2.5 inches long. If we're looking at heartwood species, our cores need to be 1.5 inches long. So when we're drilling, we want to make sure we get a core that's long enough for a proper evaluation. And I know I'm talking really fast, sorry. So if we want to look at heartwood indication, this is A49 that we were talking about earlier. So we want to apply indicators for pines and Douglas fir. We want to use this standard, and any part of the core which reacts with that indicator, including defects or pitch, it's considered heartwood. Okay, so it's not, well, for heartwood species, you do have to penetrate at least 4/10 of an inch. So even if that's heartwood, it has to be penetrated. But when you're determining a percentage of treatment in the sapwood, the part that also has to be 90% treated, you want to be able to identify that. And you do that with Douglas fir and pines using standard A49. For other species other than pines and Douglas fir, you're going to use the physical characteristics. You can tell the heartwood by looking at it, and you want to be able to identify it when you're looking at the sample for penetration evaluation. Just a note about methyl orange, there are some interferences, and the A49 standard defines those for us. The ammonia present that in freshly treated material can interfere with the color indication of methyl orange. So you want to let your sample dry a bit before you apply indicators. And it also doesn't work with boron indicator. So if you're looking at a sample and you want to know if it's treated properly for borate, you want to apply the borate indicator first, and then if you have any questions, split your core. And on the other side, look at the one side boron application and the other side heartwood, or mark the heartwood before you apply the boron indicator. There's certainly potential impacts with the use of these indicators, and you don't want to get these indicators in the assay zone for material that's going to be analyzed by titration, because that can interfere with your assay results as well. So be aware of these interferences, look at your standards, or contact your Lonza representative or your third-party agency. Make sure you're using these indicators properly and you're not affecting your sample results in the process. Okay, so then after we've applied our heartwood, we want to determine if our sample is conforming for penetration. So these are the requirements, and these are listed in your AWPA standard for pine, and these are the requirements for heartwood or thin sapwood species. And we're just going to take a closer look at that right now. So the requirement is that you have to treat at least 4/10 of an inch and 90% of the sapwood up to your 1.5 inch length core. So I've put together, let's see, and generally a charge is considered passing if 80% of your cores pass. Okay. So if we're looking at a core, and here's my example of a core, and it's 1.5 inches long. In this first example here, we have a core. We're going to determine the heartwood. And here we've used methyl orange, and the heartwood has turned red, and it is, the heartwood is indicating from 3/4 of an inch down up to the 1.5 inch mark. So then we're going to apply our copper indicator. And that, if say we use chromazerol and it turned blue, and we see that it indicated that that core was treated from the very edge of the core to 7/10 of an inch. So does that meet the requirements? Yes, we have 4/10 of an inch penetration indicated, and we also have 90% of the sapwood, so that core is conforming. So you go through that process on all 20 of your cores, and if 80% of them pass, then you're ready for the next step in this process. Okay. That is cutting the proper assay zone. And I know this seems like a little detail, but when we are looking at co-biocides, such as azoles, they come in very low. We have to actually extract those out of the wood, and we're looking at parts per million when we're doing those analyses. So we want to make sure that we don't hurt our sample assay results. If we cut them a little too deep and we have some untreated heartwood in there, we're going to dilute our sample with untreated wood, and we're not going to get a good result. If you cut them too short, you might bias your sample and have a higher retention result, and we need to know what is in your assay zone, your required assay zone. So be sure, press all the cores down to the bottom of your tray and make a clean cut for assay. It's really important. Okay, so we're moving on. Element 4, good lab practices. And this is really in my wheelhouse, and we're going to get real nerdy here, so get ready. Okay, so sample preparation. This is important. X-rays work or don't work if you don't prepare the sample properly. Okay, we want to make sure that the sample is dry and ground properly. Okay, if the sample is not dry, you will get the wrong answer. Okay, and most of the time you'll get a low answer. You're going to bias your sample low if it's not dry. If it's not ground properly, you're going to get different answers, variable answers. Every time you put it in your x-ray, you're going to get a different answer because you don't have a good consistent density. I know a lot of plants, I see this at a lot of places, they want to dry the cores. And if you dry them in a microwave, that's okay, that's fine, as long as you work out a good process to do that. But you want to dry the cores and grind them and run them. Well, that doesn't work. You need to dry the cores enough where you can grind them, and then you need to re-dry the dust after grinding. And sometime between the re-dry process, you need to stir those samples to make sure that that dust is dried throughout to 0% moisture content. And you need to check that to make sure you're getting it dry. And the way you do that is by weighing your sample to make sure after the drying process that it's not gaining it, losing any weight, that you've reached 0% moisture content. Super important. And also it's very important, especially if you're using a microwave, if you see sparks or if your sample is on fire or if you see char marks, you are degrading your sample, and that is damaging to your sample. So you may not get the right answer. It's very important. Do not burn or char your samples. Okay. Don't analyze your samples hot. This is very important. If you take a sample right out of the microwave and you throw it into your Mylar cup, this could bubble the Mylar, and it's not good. It's not going to get a good reading. So you want to put your samples in a desiccator in a place that's going to stay dry while it cools down to room temperature so you can run it and get a good reading on it. You also want to make sure that you use clean Mylar, that you change your Mylar after each analysis, and that when you do put your Mylar on your cup, check it to make sure that there aren't any wrinkles or any bubbles, and that you have a smooth assay surface. Very important. Okay, so if we're looking at XRF analysis, we kind of toss that term around. These are the kinds of elements that we can analyze by X-ray: copper and arsenic and zinc and chrome and chlorine and iron. And this is a great method for us because it's non-destructive. So we can take that dust and use it for other assays, like when we're looking at azoles or quats or other co-biocides. So this is a non-destructive way to get our results and then move on and do something else with that wood so we can see that it's been treated properly. Okay, so if we're talking about XRF analysis, what does that even mean, right? So we just we grind this sawdust and we put it in a sample cup lined with Mylar and we put it in the X-ray and we push the button and it turns green and something's happening. So what is it? What is happening inside that sample? Well, I'm fixing to tell you, so get ready, here we go. When samples are exposed to X-rays, the energy causes changes to occur within the sample's atoms. So we're gonna take a little deep dive here. We're gonna look at an atom. We're gonna see what's happening when our sample is actually in the X-ray. So let's take a look at that for a minute. Okay, so when the sample closes up and the X-ray light comes on, X-rays collide with the atoms. Okay, so here's this yellow thing right here. That is the X-ray colliding with that atom. And there are electrons that are floating around the nucleus. Well, when electrons are exposed to those X-rays, those ones nearest the nucleus, they get kicked out of their orbit, right? So they get ejected. And what happens is this makes that atom unstable. That can't happen. Atoms don't want to be unstable. So what happens in that vacancy, another electron will move down from a higher shell and fill that void. Well, as these shells go further and further out, it takes more energy to bind them to the nucleus. So when an electron drops from one orbit to another, it loses energy. It takes less energy once it's down in that lower shell. So that extra energy is the energy that we are measuring in an XRF. So let's see, make sure I'm not forgetting anything here in this process. The amount of energy that we measure is consistent and is unique to each element because the distances between the electron shells is consistent and unique to each element. So the more elements that we have, so if we have a lot of copper in our sample, and so we have more atoms, more copper atoms that are being exposed to these X-rays, the more electrons we have jumping out of their shells, and then the more electrons we have going down to fill that, the more energy we have being put off by that sample. So we can measure that, and that's how we come out with a result using XRF analysis. And I think that's just the coolest thing ever. So what I want to do is, I know you've had a really hard day, so we're going to take a little nerd break here. We're going to let the nerdiness flow through us, okay? So we're wrapping up, I promise. But that was just kind of fun because I think we put our samples in that X-ray machine, and most of us don't know what's happening inside there. And I think it's pretty cool to actually know why and what we're measuring when that process is going on. So moving on. How do we know that our X-ray is working properly? And we do that with XRF controls, okay? So the AWPA standard says you have to do it, so you kind of have to do it anyway, but it's for a good reason. And we want to do it because it lets us know that our equipment is working properly. So there are some very simple charts that you can get from your agency, or I'm sure that Lonza has in your systems, in your computerized systems, a way to track these control samples. And we use these charts to make sure that you are getting the right answer, that something hasn't happened to your analyzer since you went home over the weekend. And also it lets you know if your instrument is drifting. So if your calibration is trending high or trending low and you need to make an adjustment, these control charts are really important. So even though it's kind of a pain, you have to do it. So let's work on that. Restandardization. If our charts tell us that something is wrong, if our error is greater than 5%, which is what the AWPA standard allows us to be within 5%. So if we come in and we run a control and it's 10% different than what we know our sample should be, then we have to do something. So the first thing we can do is at first redry your sample and rerun it and make sure you've run it and you have clean mylar and smooth mylar, and you've done all those things, then you might need to restandardize. And if that doesn't work, then you might need to recalibrate. So that's why the control sample is so important. You can restandardize on a routine basis. I personally recommend only restandardizing when you need it, when your control charts say that you need it, because you can mess things up in that process and not even be aware of it. So if it's not broke, don't fix it. That's my philosophy most of the time. Okay, so if you do need to restandardize, make sure you're storing your setup samples properly. Keep them clean and keep them dry. Okay. So calibration. Usually calibration is performed by trained personnel, LANSA, Hitachi, Rigaku, or your third-party agency, okay? And they come in and do this for you, but I wanted to tell you a little bit about it. You might do it. There are some plant operators that do calibrate, and if you do, there's important things that you need to know. Okay, make sure that your wood samples are dry and your cups, your mylar cups are clean, but you want to make sure that your standards are prepared, including particle size and sample volume and the type of sample cup and the film and the moisture content. Make sure that your calibration samples match your unknown samples, because this is how calibration works, okay? We measure samples of known values and we plot those results on a curve. And then we measure your unknown and we plot that measurement on the curve, and it gives us our result. So it's very important that your calibration samples match your unknown samples. Okay, so we're going to review this. What do we need to know for good lab practices? We need to pre-dry your cores before grinding. You need to grind samples to a consistent particle size. This is very important, especially with new analyzers, okay? Don't burn your sample. Dry your samples to a 0% moisture content. Stir your samples during drying. Use caution to prevent loss of sample. You need the whole sample, as much sample as you can get, and you need it to be homogeneous. And then you need to keep your sample in the oven or desiccator until you're ready to analyze it. Let it come to room temperature before you analyze it, okay? And then clean mylar, consistent samples with your calibrations. Change your secondary window mylar too. Make sure that you keep that clean. It's very important. And that you're using the right density for the product. Consistency. This is it's elemental. I know that sounds cheesy and corny, but it's true. We need to treat every sample the same exact way every day. Okay. And then what do you have to sample? What are your sampling requirements? You need to sample every charge, and you have to make sure that every charge is conforming before it's shipped. And then you need to you can take additional sets if you need to. That's what we talked about earlier, but you need to average those results. And you need to send in at least 1 in 20 for total assay if you're not able to analyze the entire, all of the components of the preservative system where you are. 1 in 20 have to be sent out to a lab for total assay. Okay, so there's a part in the standard that says this language here. This is exactly what the standard says. For preservatives containing multiple active biocide components where at least one component is readily analyzed in each charge at the plant site, the retention of the unanalyzed components and the total retention in each charge may be calculated based upon the analyzed components using a documented methodology. What does that even mean? Okay, well, let's talk about that for a minute. It means that you're running copper every day, but you're not running azoles or your co-biocides every day. So you need to use data from your agency, from your chemical manufacturer to know what target copper you need to be looking for every day. If you're always running low, like in the beginning of this chart, you're running lower than your agency on the same dust or lower than your chemical manufacturer on the same dust. You may need to target a higher copper number every day. If you're running higher and the data is showing that consistently, then you may need to lower your target copper number. If you're comparing very well with your agency or your chemical manufacturer, then you probably can keep that target copper every day at the minimum. But this is data that you need to look at before you determine what your in-plant copper accept target is. Okay, that's very important. Okay, so if we have a product that doesn't meet the standards, if we find something non-conforming, we need to first isolate that product for correction. And you can't just take the quality marks off. You have to try and retreat that material at least once. At least this is for products under M22. You have to try and retreat and meet certain retreatment conditions before you remove the quality marks. And you need to document your actions so that when third-party agency comes in, they can see what you've done and how you've done it and how you've handled that nonconformance. And then element 5 is to know your resources. You have help, you have assistance. Lonza Technical Services, they have a lot of information that they can provide to you to help you through this process and to keep you as efficient and as knowledgeable about what you're doing every day as possible. Both your third party and your Lonza Technical Services use those resources. They know the product and they're there to help you do what you do every day. Okay, so just a few minutes on third-party quality control. Our mission is quality together. And I know a lot of people think, oh, they're just there to take samples and tell us what we're doing wrong, but that's not true. We're there to, of course, enforce the standards, but we're also there to give you the information that you need to do what you do every day, to have a quality product together. And so we do that through AWPA standard M22, where you're looking at M25, we're looking at M22. And that provides a method for third-party agencies to evaluate data based on average percent core percentages and lower confidence levels. And this is applicable to sawn lumber, sawn timbers, and engineered wood products. And it provides a line that we can use to determine satisfactory performance by treating plants where there used to not be one. So this standard has done a lot for the way that third-party inspection agencies evaluate treating plants. And it's all based on production categories. So how do we define a production category? And I went by that slide way too fast. I don't know if I can go back. We're going to look at preservative and species and retention level. That makes a production category, and everything that we look at is defined by that. So our required sampling, we have to sample ranges of charges since the last time we were there to make sure we're covering your production. We have to look at 5% of production or 5 charges for each production category each time we come in to visit you. And then we can sample at higher rates, but we can't count those samples. So it would be for information only. And then we have to, right now, we have to get a minimum of 1 sample per production category per quarter and a full set of 20 samples every year. Bias samples can be taken and they're there to help you if you need to assess cycle changes or investigate problems. We can do bias samples as well, and they're not counted in your M22 data. Okay, so there is an upcoming change to AWPA sampling rate. This will help for production categories that have low volume. Right now, we have to get 20 samples per year, even if you only treat 30 charges in a year, we still have to get 20. So AWPA is making a change to that requirement, and this will help us all stay qualified. What we have to do is we still need to get a minimum of 1 sample per quarter every 3 months. We need to do that. And at the every 12 months or in the previous 12 months, we need to make sure that we get either a full sample set or 5% of your production. And this really levels the playing field and is going to make it much more practical to keep up with those sampling requirements. And then how does M22 actually work for penetration evaluation? And I'm sure most of you guys are familiar with this, but this is just an average percent core conformance of your most recent 20 charges that the agency has looked at. It's set at the same rate as your individual samples. You need to have an 80% conformance rate. So over the last 20 samples, 80% of those cores need to have passed in order for you to be in a satisfactory inspection status. And then there's a single charge evaluation. So if you have one charge that like super fails, looks terrible, it's less than 60%, then we have to follow up just based on that single charge evaluation. And then we have, just for a quick look, this is what your M22 chart, a sample of that for penetration. We have the line drawn, the red line drawn at 80%, and we see individual charges results in blue. And then your APCC is these green triangles. We need to make sure that they stay above the line. If they were to go below the line, then we would have to go through a status drop and follow up on that and make sure you get that corrected. So how does it work for retention? Well, it works through a lower confidence limit. So we're looking at 20 samples again, the last 20 samples that the agency looked at. This is a little bit more complicated that we look at for retention, and I'm going to take you through it, how we actually do that. So we look at the last 20 samples, and we look at the median. We calculate the median. I'm going to kind of skip over this really wordy stuff here and talk about that more here in just a minute. But the single charge evaluation, we need to talk about that. If we have a sample during an inspection that is less than 75% of the minimum, that will trigger a follow-up just for finding one that's severely non-conforming. So let's talk about how we calculate a lower confidence limit. So first we need to calculate the median of the most 20 samples. Here's the calculation. You really don't need to know it, but I feel smarter if we just look at it for a minute, okay? Then we also need to calculate the standard error. So that uses the standard deviation of the 20 samples that we have, and then it kind of extrapolates that, and it looks at the standard error, estimating the error for if we looked at everything. So we calculate the standard error then, and then we have this calculation for the lower confidence limit. So we take your median and we subtract your standard error times the critical value, or the factor, the confidence factor. So for 20 samples, that confidence factor is 1.7. If you just started a new production category and you don't have 20 samples, that number will be a little different. It'll be a little higher because we haven't looked at it at as many samples yet. But we're always going by 20 if we have 20 available. So the number is usually 1.7. And that's how we calculate it. And this is how we chart it. This is a sample M22 LCL chart. And I'm sure you guys have all seen this, but if we look at it for a minute, the red line is drawn at the minimum retention. The blue dots are the individual charges. And then this is an inspection, this is an inspection. And each time we have an inspection, at the end of it, we calculate your lower confidence limit, these green diamonds. So that at the end of this last inspection, we can see that your lower confidence limit was above the minimum. So this plant would be in routine status. Everything looks great. So if you were to fall below the line, then we have a set way that we try to bring about correction. Okay, so if everything looks great, you're in routine. If you have something that goes wrong and you get placed on increased, then if you don't make correction and you have failures the next time, you would go to warning. If you've made correction, but it's not enough to move your requirements above the lines, you would stay where you are and increased as long as you don't have any failures. But if you continue to be below the required lines and you're having failures, then you would go to warning and eventually into disqualification. We don't want that to happen. Usually your agency and everybody is on full alert by the time you get to warning, and we can get that corrected so we don't get in that situation. Okay, so after having said all that, AWPA is making some changes to the lower confidence requirement. Right now, the lower confidence limit is set at the minimum retention. So whatever the minimum retention is for the preservative you're treating with, whether it be the total or the individual components, it's set at the minimum. So if you're treating with copperazole ground contact to a 0.15, your minimum is a 0.15. But AWPA is making some changes that is going to require an increase to that, 5% above the minimum. So let's talk about that a little bit. Why? Why are we doing this? Well, we implemented, like I said, M22 several years ago. We've been tracking industry conformance since then. And we can see that we've been having improvement. Right now in 2019, the last time we looked at it, we were 89% conformance. And when I say percent conformance, I mean agency samples, all of the agencies, all of the treaters, we put all the samples that we took together, and 89% of them passed for retention and 98% of them passed for penetration. It's pretty good, right? And it's been getting better every year. So why would we make this change? Well, we were seeing some M22 charts that look kind of like this. And you can see if you look at this chart, there's a lot of blue dots below the line. This example is a production category where only 70% of the samples passed the inspection agency's assay results. And you can see that M22 only put them in increased inspection 2 times. So there was no real correction to this type of issue. It just was really slow to react, and it ended up with some plants. And if I pull up this next one, this is a distribution of conformance rates by plants. The good news is we have a lot of plants that have conformance rates of 90% and better. But we have this group of data right here of plants that have conformance rates that are in the 70s and low 80s. And so we wanted to not hurt these guys that have really high conformance rates and bring up plants with lower conformance rates, bring those up a little bit. So we looked at the data, we split everybody up into 3 different groups, plants with less than 80% conformance rate, plants that were 80 to 90, and then plants that were above 90. And we looked at their average conformance rates, and we drew some lines to look at this data and where we should raise the LCL minimum to. And if we look at 1, which is the minimum requirement where it is right now, you can see that there are, in this last group here, this last line, that is the high 90% or above conformance rate plants. No plants in that group have an average of 1 for their LCL for the year. If we raise it up to 0.5 or 0.05 or 5% above the minimum, we can see that we don't affect very many plants in that high conformance group, but we affect a lot of plants that are in the low conformance group. This blue line is the 80% and less conformance rate. And if we raise the minimum just by 5%, we will affect those plants. And the point is to not affect those higher conformance rate plants at all. So that's why the committee decided on a very conservative 5% raise. So what that means in practical real world every day is your current, as an example, CAC 0.15, the total LCL requirement is 0.15. So if we multiply that times 5%, we get a 0.158. And if we round that to 2 significant figures, our LCL minimum will now be a 0.16. That does nothing to your individual sample conformance. Every sample will be treated just like it is. The minimum retention stays the same. If you analyze a sample and it comes out to a 0.15, and I analyze a sample and it comes out to a 0.15, it passes. The only thing that's being raised is your LCL minimum. So when we draw that line and we calculate your LCL, it has to be a little bit higher. And that task group, I just want to let you know that that task group is in place, and we're going to be monitoring these results, and we're going to be measuring the effects of this change and making adjustments if necessary. So if you have any questions about that, feel free to contact me later or contact Lonza for more information about that. And then we're also making some changes to our M23, and that is the in-plant QC evaluation. There's certain things that you have to do every day at your plant. You have to check every sample. You have to do your control chart. You have to do all the things that AWPA says that you have to do. And we're there, and when we come in, we have a checklist to make sure that you're doing those things. If you're not doing those things, well, I have them all listed here. This is a list of all of the things. Your charge numbers are right, your quality marks are formatted properly, just all the things that go into doing what you do every day. And if you're not doing any of those things, when we're assigning you points, each thing has a different point value that you're assessed, and points are bad. If you get too many points, then you're going to go on increased or warning status, and you're not going to be able to stay qualified if you're not doing those things. Well, that was a little bit clunky, and it really wasn't bringing about correction for plants that were not doing all of the things that they needed to do, and it was making it hard to bring about that correction using this point system. It just wasn't sensitive enough to do what we wanted it to do, or what it was intended to do, actually. And what it's intended to do is to make sure that everyone is having to meet the same requirements, and all treating plants are on a level playing field. So we've changed it up a little bit so it will do what it's intended to do and keep everybody on the same level. And what we're going to do is we're going to divide up these requirements into what's called process IQC and product IQC. And the process are the kinds of things they're listed here, like your incising, your drying after treatment, your charge numbers, your analytical equipment checks, or your labels. Those are process requirements. Now, if you fail to meet one of those, we're just going to notify you, and you're going to go on a follow-up status. So we're not going to come in on an increased frequency. We're going to come in on our regular inspection next time. And if you haven't fixed that the next time, then you would go on warning. And if you haven't fixed it the next time, then you would reach disqualification based on your implant status. Now, these product IQC requirements, those are the biggies, right? These are the things that we need to be doing on our product to make sure it's conforming. If you don't retreat something that you found non-conforming and you ship it anyway, or if you're not checking your product, you're not checking every sample, those are big ones. So if you're not doing those, you're going to go on warning right away. And if you're not doing them the next time, then you would reach that disqualification status the next time. So no more points. I think that it will be fair, and it will keep everybody where they need to be, and it will do, do a better job than the way we were doing it with the point system before. So that's why I have the next slide that kind of goes through what I just said as the actual way we would implement the new standard. So having said that, these changes that I was talking about, they will not go into effect until the Book of Standards is published this year, which is usually sometime in the spring. And then I'm sure that we'll be working that out with ALSC to get you a transition time. So I just wanted to let you know about those things coming up. And I'm sure you'll hear all about it as we get closer to these things being the standard. And I did forget to mention one other thing. For borate treaters, if you are using a dye that is a penetrative dye, you can use that. There's a new change to the standard, and it will be standardized that you can use that dye as a surrogate. And that's awesome. So we can kind of limit the chemicals that we're using. And so that is another change to the standard that will also go in effect in May. And I forgot to mention that when we were talking about indicators before. So just to recap, I am done. The essential elements of what we've been talking about for a while now, that seems like a lot longer when you go through it, is to use your third-party data to validate and improve your implant quality control program. We're not just there to enforce standards. We want to help you meet your treatment goals and make you more efficient and more cost effective. And we have data that's there for you to use. Utilize your third-party field and laboratory staff. They can help you with your incoming product, with grades and things like that. And lab staff is there to help you. If you're not confident in your answers or you're seeing problems, let us know so we can help you. And also use your Lonza Technical Services. They are there for you. I know they have tons of data that can help you do what you do every day. And if I don't have any questions.
Hey, Kim, we have one question.
Okay.
Dye is okay as a surrogate?
It will be. It's going through the standardization process. Okay, so there was a proposal that was put forward last fall to T2 to add borate dye as a surrogate for the penetration indicator. So it's not standardized, hasn't completed the standardization process yet, but I don't see any reason why it wouldn't get approved. It's pretty far down the line. And so when the new book comes out, that will be allowed under the AWPA standard. Yes.
Okay, thank you.
Okay, thank you guys.
Thank you, Kim. Well, we made it to the end. Thanks everyone for attending this year's virtual lawn plant operator seminar. Once you leave today's webinar, you will receive an event survey. Your participation will assist us in continually improving these seminars in the future, hopefully in person. You will also receive a follow-up email within 24 to 48 hours with a link to view a recording of today's webinar if you didn't get it the first time. I would also like to mention that the California participants will still need to fill out the final SurveyMonkey quiz that's coming your way. On behalf of Lawns of Wood Protection and our presenters, thank you for joining us today and have a great rest of your day. Thank you.
Thank you, Grady. We appreciate your moderating the seminar today.
Well, I appreciate your and Sarah's help. Thank you, Belinda.
Thank you. Bye, everybody.
Bye, everyone.
Bye.
Lawrence Cook, how do I get 6 credits for Idaho? I will take care of all of the states for you. I will send in all of the requirements, all of the sheets that they need to credit you, your account for your credits. So nothing for you to worry about on your end.
Okay, Sarah, I'm ending the webinar, okay?
Sounds good. Thank you, Belinda.
All right. Have a good night. I'll talk to you tomorrow.
Thanks, you too.